Hello, everyone. All right, so first of all, welcome to our Kotlin course. Thanks for choosing it. So who do you think you are? In other words, who should take this course? Who's going to benefit most? I'll tell you, this course aims to teach Kotlin programming for Android developers, if you're a beginner, all the way through the advanced level. So basically anyone who does not have that accessible knowledge of Kotlin programming, anybody who wants to learn Kotlin programming language, and let's say you're already developing an Android application using Java programming, well, you're going to want to take this course too. So what do you think you're going to learn in this course? Well, I do want to give you all the information about this Kotlin programming language. You will find the answers to such questions such as, what is Kotlin programming language? What is it used for? Why it's emerged? Why you want to use it? And then we'll be able to open your horizons a little bit about this Android ecosystem, all right? Then we're going to install programs necessary to learn and use Kotlin programming language, and you'll see how hands-on practice will get you up to speed fast. You're going to learn variables, data types, arrays, operators, control flow statements, and loops, all within this Kotlin programming language in great detail. Then we're going to jam in some object-oriented programming. So in this context, you're going to learn function, class, object creation, encapsulation, inheritance, function overriding, abstract classes, and interface in great detail. So that means that by the time you finish this course, you will have some great knowledge of this Kotlin programming language. And then you won't be asking me, what is Kotlin programming, right? Now, if you do happen to come up with a question that you just can't seem to find the answer for while you're watching this course, well, you can always send us your question from this Q&A section below the course videos. You can also share the sections or codes that you think need to be corrected, maybe updated, and we'll tell you why you're wrong. Nah, I'm just playing. I want to thank you very much for being in touch. But we promise you that we will make the necessary updates as soon as we can. What does that mean? Well, you're always going to have the most up-to-date information and content. So I think you're ready. Why don't we just begin the course? I'll see you throughout. Well, hello, friends. So in this lesson, we're going to talk about the Kotlin programming language. Now, first of all, question probably pops into your mind. Wait, what? What is Kotlin? Well, that's a good question and a good place to start. So I'll tell you, Kotlin is an open source, statically typed programming language that supports both object-oriented and functional programming. So the Kotlin programming language runs on the Java virtual machine that we typically call a JVM. Kotlin language provides syntax similar to languages such as Java, C#, Scala, but it takes its name from the Kotlin Island, which is a Russian island in the Gulf of Finland, in case you were wondering. Now, of course, we said that Kotlin is a static language, so wait a minute. What the heck is that? Were you even listening after I said static language? Yeah, it's kind of an odd term, huh? But it kind of gets your wheels spinning, too. So static programming language is such that every variable type is declared from the very beginning. So that is, when we define a string value, we write string at the very beginning. When we define a numeric value, we write types such as int, double, float, at the very beginning of the variable. So therefore, variable types know what these types are even when the program isn't running yet. Okay, so all this means that while the program isn't running yet, if you've made a mistake, it'll warn you and wait for you to correct the mistake. So languages such as Kotlin, Java, C# can be given as examples of static programming languages. Also, there are dynamic programming languages that you might be familiar with. The dynamic programming languages will be languages in which the variable types are determined at program runtime. So when you create a variable, you do not need to specify the type of that variable, whether it's a string or an integer, whatever. So languages such as Python, JavaScript can be given as examples of these dynamic programming languages. Awesome. Glad we got out of the way. All right, so the Kotlin project was first started in 2010 as open source. So it's a completely free language, and its first official version, 1.0, was also released in February 2016. It's a long time, huh? But Kotlin was announced as an official Android development language at Google I/O 2017. That's why the Kotlin programming language became the third fully supported language for Android after Java and C++. So now, Kotlin is officially supported by Google for Android development, meaning Android documentation and tools are designed with Kotlin in mind. Good to know. So I would also like to mention one more thing. Kotlin is 100% interoperable with the Java programming language. And great care has been taken to ensure that your existing code base can properly interact with Kotlin. You can easily search Kotlin code from Java and Java code from Kotlin, and this makes adoption much easier and lower risk. Now, there's also an automatic Java to Kotlin converter built into Android Studio, which makes it even easier to migrate existing code. And all this means that if you already know the Java programming language, you can learn the Kotlin language, well, I would say a whole lot easier and faster. Now, it's okay if you don't know. You don't need to worry. In this course, I'm going to teach you Kotlin programming language step by step. All right, so what are we aiming at with this Kotlin programming language? Well, I'll tell you, by using the Kotlin programming language, you can do more with fewer lines of code. And that means a language using coding has a much simpler, more understandable structure. Commands are clearer. You can also compile your projects faster with Kotlin. So then, wait a minute. What can you do with Kotlin programming language? Well, in fact, you can develop web applications, desktop applications, and Android applications by using Kotlin. Of course, Kotlin is often used to develop Android applications. So, in fact, there's a lot you can do. So in this course, we're going to learn how to develop Android applications using Kotlin. All right, my friends? I think that covers what the heck Kotlin programming language is all about, how it's emerged, and some of the advantages of Kotlin. So we'll take a short break here if you want to. In our next lesson, in any event, we will give you some information about the Android ecosystem, which you're going to have to know first, okay? So I want to see you in the next lesson. Well, hello to everybody. So we're going to talk a little bit about this Android ecosystem for this video. So we'll start without wasting any more time, because we got to get to it. We got a lot of good stuff to do. All right, be quiet and tell me. You betcha. Android is an operating system designed for use on mobile devices. The Android operating system was originally created for use in digital cameras. Bet you didn't know that, did you? So the Android operating system is developed primarily for use now on smartphones and touch tablets by Android and Google. Google bought the Android company in 2005, and the Android operating system was released in 2008. Although Android is developed for smartphones and tablets, today it's still being used in Android television, smartwatches, Android Auto, and Android Wear devices. Android Auto is the car smart multimedia system, in case you weren't aware. So, Android operating system is used in more than 100 languages today. That's 5.22 billion people who are using a mobile phone today, and that equates to 66.6% of the world's total population. Also, more than 2 billion people use the Android operating system as of May 2017. Google Play has more than 2.8 million applications published, and more than 6,000 applications are published on Google Play every day. More than 20 million application developers will be needed in the next few years. Yeah, I'm looking at you, right? So this means that you need to learn this Android application development really, well, I'd say kind of quickly, but thoroughly, but quickly. So I believe this course is going to be really good for your process, okay? So after this course, you will be a very good Android application developer. All right, well, at least a good one. Anyway, let's get going. So, another motivation factor, let's talk a little bit about salary. I know you wonder how much your salary is going to be. Well, I'll let you in on a little thing here. Junior Android developer salaries are more than $55,000 per year in the U.S., but I believe you're going to make more. Middle-level Android developer salaries, more than $100,000. Senior-level Android developer salaries is about $130,000 US dollars per annum, as they say. So this chapter was just to give you some, general information about the Android ecosystem. Hope it was useful. After this video, we're going to start to install Android Studio. If you're ready, let's go. All right, hello friends. So we are in the next lesson. So that means we're going to learn some programming terms that are common to almost all programming languages. And I think that if we all get on the same page about this, it's going to be very useful for you. So we're only going to talk about the basic meaning of most of these terms, because in our course, we're also going to learn the detailed usage of the related terms whenever it comes up and appropriate. So if you're ready, let's get started. So a package is an organized module of related interfaces and classes. Packages are used to organize classes that belong to the same category or provide related functionality. Now, in object-oriented programming, a class refers to a set of related objects with common properties. So classes and the ability to create new classes render OOP a powerful and flexible programming model. So, for example, there might be a class called Shapes, which contains objects which are triangles, pentagons, squares, and circles. You follow? So that an object is a combination of related variables, constants, and other data structures which can be selected and manipulated together. An object can include shapes that appear on a screen or like the age of students in a school. Object-oriented programming, OOP. So this is a model defined by programmers that revolve around objects and data rather than actions and logic, okay? In OOP, it's not only the data type of a data structure that's defined, but also the types of functions that can be applied to it. So through all this, the data structure becomes an object that consists of both data and functions. So languages that use OOP concepts are Java, Kotlin, Python, etc. A function is a block of code that can be referenced by name to run the code it contains. Argument, or arg, is a value that is passed into a command or a function. For example, if sqr is a routine or function that returns the square of a number, then sqr4 will return 16, all right? So here the value 4 is the argument, and similarly, if the edit is a function that edits a file, then in edit myFileText, well, you guessed it, myfile.txt is the argument. All right, my friends, here's a few of the terms that you're going to hear often in our course. So we'll take a short break here, and I'll see you in the next lesson. All right, friends, glad to have you back. So on this lesson, we're going to prepare our computer to write code in order to develop Android applications using the Kotlin programming language. Now for this, we will first install the JDK, or Java Development Kit. Now earlier, remember we said that this Kotlin language runs on the Java virtual machine. So therefore, in order to develop applications using Kotlin, we will need to install JDK onto our computer. Now, before we move on to the JDK installation, I would like to briefly explain the concepts of a Java development kit that we refer to as JDK, a Java virtual machine, or JVM, and Java runtime environment, or JRE. So this Java development kit, it's a software development environment, all right, and it's used to develop Java applications. But this package contains all the tools that you need to develop with Java. If you want to develop and run applications, you will need to install JDK onto your machine. It actually includes Java runtime environment and other developmental tools. Development tools are things like compilers, Java debuggers, and other things that you'll learn. The JRE, or Java Runtime Environment. This is a software package that combines libraries, the Java virtual machine, and other components to run applications written in Java. Right? So the JRE is the runtime portion of Java, and this is all you need to run it in your web browser. It includes Java Virtual Machine, or JVM, and libraries. So the Java Virtual Machine is a virtual machine that runs Java programs. So when we run the Java program, the Java compiler first compiles your Java code to bytecode, and you get this bytecode by compiling the .java files into .class files. .class files contain bytecode understood by the JVM. So in short, if you are a Java or Kotlin programmer, you will need the JDK to develop and run applications, and this package will also include the JRE and the JVM. Yeah, so there you go. That's a brief little overview about the JDK. So we'll move on to JDK installation. So first up, you just have to open your browser, and here I'm using Google Chrome, but I think you can use any browser you want. Let's get too extreme here. Anyway, now let's write download JDK in the search bar. So after pressing the enter key, I'll just open the first of the results, namely the Java Standard Edition, or SE, Downloads Oracle Technology Network page. So if you notice, the most up-to-date version of Java is Java 16. Now, if you do see another version here, don't worry about it. The JDK installation is the same in all versions. So you can successfully complete the JDK installation just by following the next steps. So I'll click on JDK download, and that's the link in the Oracle JDK section here. So this page that opens, this is the Oracle JDK page. I want you to notice there's an important warning text here, okay? Oracle JDK changed its license April 16, 2019. So in other words, while personal and development JDKs were free, those used for commercial purposes have become paid. So for that reason, Oracle offers us the Open JDK version, which is open source. So that's why I'm just clicking on the jdk.java.net link here. So from this page it opens, I'll choose JDK 16, which is the most up-to-date and ready-to-use version. Now from this page it opens, we can download the appropriate JDK for our computer. And as you can see, there are JDK installation files for Linux and Mac and Windows. Now my computer is operating with Windows 64-bit, so that's why I choose the zip option from here. And you can see that my download has started. I hope yours has too. So, of course, depending on your internet speed, it could take some time to download. So I am just going to stop screen recording here, and then I'll come back when the download is complete, and we'll just continue where we left off. Happy downloading. All right, my friends, so my download is complete, so I'll continue by clicking on the arrow icon right here and select Show in Folder. All right, so now I'll need to extract this file here. Now, of course, you have to have a compression or decompression program on your computer to be able to do this. If not, you can always download it from the link that I've added right into the resources of this lesson. So now I'll just right-click on the zip file and select Extract Here. All right, so as you can see, we've obtained a JDK folder. And now we will move the JDK folder to the Java folder that we will create in the Program Files folder. So for this, I just cut JDK folder by pressing Control-X on the keyboard. And let's open up Program Files by selecting this PC and local disk C. And now let's create a folder called Java here. So I'll right-click with my mouse, select New, Folder. I'll just name this file Java. So now I'm pasting the JDK folder that you saw me download earlier. All right, so we have now installed the JDK on the computer, but we do have one last step to do. We need to define the path of the java.exe file in the JDK folder here to the operating system. So for this, I can just open up JDK folder, and I also open up the bin folder. All right, so let's find the Java file here. All right, so I found the Java file. Now let's define the path of this file to the system. All right, so first I just click on the address bar at the top of the window and copy the file path here by pressing Control-C right here on the keyboard. Now let's define this file path to the system. So I'll right-click on this PC from the left side and select the Properties option from the drop-down menu. And from this window that opens, well, you can learn some of the basic information about your operating system, should you need to. So now I'll select the Advanced System Settings option right on the right. I'll select the Environment Variables option from the System Properties window that opens. Now, if you notice, there are two different sections here. We're going to use the bottom section, namely System Variables, to define the JDK to the system. So that means after selecting the path option from the section here, I choose the Edit option. And here we'll just paste the path to the Java file in the bin folder. So to do that, I'll select the New option and paste the file path we just copied by pressing the Control and V keys together on the keyboard in this field that opens. All right, so that way we have now defined the JDK file to the system. So the meaning of this process is just like this. If you want the operating system to run Java, the operating system has to know where the Java exe file is. Otherwise, it's not going to be able to run it, okay? So for this reason, we have defined the folder where the java.exe file is located on our operating system. And finally, I can press the OK button. So I press OK once again. And there you have it, my friends. You've just watched me complete the JDK installation necessary to develop applications using Kotlin. I hope you did it along with me. If not, catch up and install it, because we're just going to take a short break here. And in our next lesson, we're going to install the Integrated Development Environment, or IDE, for Android Studio. And this, of course, will be necessary to develop Android applications. All right? See you in the next lesson. All right, hello friends. So in this lesson, we will download the IDE that we will use to develop Android mobile applications, which is also called Android Studio. So now we'll do the necessary installation procedures. Android Studio is a completely free platform. It can be downloaded and used by anyone, but then you have to learn how to use it, huh? Now, I also want to explain a little bit that IDE is a software application that combines all of the features and tools needed by a software developer. So a developer would be able to debug, run, and test applications with IDE. And because it provides useful debugging and testing features, it's all in one handy place. So IDE helps us in quickly navigating to a type without really needing to worry about our project. It also provides auto-completion. That means you start typing a part of a function or a class name and press a shortcut combination, then the rest of the name will be automatically typed in for you. I love it. Now, all these features are pretty good reasons for you to prefer an IDE. But I'll tell you something for nothing. The most used IDEs for Kotlin are Android Studio and IntelliJ. I prefer Android Studio, so I'm going to introduce Android Studio to you, and I'm going to write Kotlin programs on Android Studio during this course. All right, how's that? So, if you want to continue with me, let's do these necessary steps to download Android Studio now. All right, so first up, we need to open our browser. So in the search bar, we just write Android Studio Download. Press Enter. And here we will open the second result, namely Download Android Studio and SDK Tools. Now, if you pay close attention, the site is the developer.android.com site, right? So this site is a site that Android developers must follow, my friends. So you can follow the latest developments, updates, and documentation required so that you too can develop applications on and for Android here. All right, so we can now proceed with the download. So this looks like the most up-to-date version of our Android Studio. Now, of course, I do want to point out something here. Android Studio is continually updating. So even while I was creating this video, the most current version is 2020.3.1. So this version is called Arctic Fox, right? So this version might appear different to you. But pretty much the download and installation process of Android Studio is the same. So it just won't make a difference. But if you do see a different version here, I just don't want you to worry. All right, so just by following these steps, I'm going to explain how you can perform the download and installation process, and then we'll get going, okay? Now, before proceeding with the installation process, I would like to show you these Android Studio system requirements. Now, at the end of the page is the system requirements section. So just review the section. You can find out whether the computer you're using is sufficient enough for Android Studio. Just a little disclaimer here. If your computer does not meet these specifications here, you could, well, buy a new computer. Or you can just change some of your computer's features, right? For instance, if your computer has 4 gigs RAM, you could increase it to 8 gigs relatively simply and inexpensively. You could even drop back a version or 2 of Android Studio, but, you know, I would pretty much recommend you to just move forward. Whatever it takes, right? But anyway, let's just now download Android Studio. So I'll open up the top of the page, and if your computer's operating system just happens to be Windows 64-bit, it'll pretty much look like mine, and you can start the download process just by clicking the Download Android Studio button here. If your computer's operating system doesn't happen to be Windows 64-bit, well, you can click on the Download Options tab on the left. So when you click on that tab, see the download links for 64-bit, Mac 64-bit, Linux 64-bit. But yeah, you probably noticed there's no option for 32-bit operating systems. So it's time for you to get into the 21st century if you need that. I'll tell you why. Because Android Studio doesn't support 32-bit at all since version 4.0. So if your operating system is 32-bit, well, just go ahead and download Android Studio 3.6.3. All right? So this is the last version of Android Studio before 4.0. No shame in it, my friends. This is how we learn, right? Anyway, for this, we could click on the Download Archives link. And then from the window that opens up, we just need to accept the relevant contract terms. So for this, I could click the Agree with Terms button. And as you can see, we have accessed all of the versions of Android Studio. So we're a pretty versatile bunch, huh? So from here, you can find the 3.6.3 version of Android Studio and use the download link required for 32-bit operating systems. So whichever version you want, let's start the download process. So of course, I'm going to open up the previous page since my computer's operating system is Windows 64-bit. That means I will download the appropriate Android Studio. But no matter which page you're on, just click on the file with the extension .exe here. And in order to download the Android Studio, we will need to accept the terms of the contract. After confirming the checkbox here, the button that we will use to download Android Studio becomes active. So clicking this button will start the download process. So I'll just click the button. And yeah, so here you can see that the download has started. And yes, just like before, the download process may take a little bit depending on your internet speed. So I'm just going to fast forward through this. Wow, that was fast. And now you can see that the download is complete. So I'll click on the arrow button, well, it's really an icon, to the right of the downloaded file and select the Show in Folder option. So here we can view the file that we've downloaded. So I'm just going to double click on this. Windows asks, do you allow this application to make changes to the computer? Yeah, that's quite a warning. I'm just going to press yes. So the warning might not appear for you. It's not really important. But whatever you have to do to install, you'll install, because here you can see the installation screen opens. And here we click on Next. And once again, we press Next. Right, so the location where the files will be saved will be written to, so you can change this location or you can just keep it wherever it is by default. I usually prefer, actually, the default file path. That's why I just press the Next button, once again, without making any changes. That way, if it knows, I know. So here it asks if we can create a shortcut for Android Studio. Now, in fact, it's reading my mind because I do want to create a shortcut. You don't have to if you don't want to, but just confirm the checkbox here. So I'm not going to make any changes. So now we can start the installation process. By clicking the Install button here, we will start the installation. And as you can see, the installation process begins. And just like downloading, this process may take some time, so I'll just fast forward. And yeah, that was a great installation. And now it's complete, so I'll press Next. So it states that the installation process of Android Studio is now complete. Yay. So if we want Android Studio to start after the installation process, we just need to check this checkbox. I'm going to uncheck it, though. And we're going to start Android Studio together. So please do that, and I'll press Finish. All right, so that completes the necessary installation process of all these things. So, in fact, you could call this the pre-installation of Android Studio, because we haven't quite completed the installation of Android Studio yet. We still need to install the SDK. That we're going to do in the next lesson. So we'll take a short break here, and I want to see you there. Well, hello, friends. So in our previous lesson, we downloaded Android Studio to our computers and installed it. But remember, the installation process is not completely finished. So that means in this lesson, we are going to complete the SDK installations. We're also going to examine in good detail how to create a project in Android Studio. All right, so if you're ready, you must be chomping at the bit. Let's get started. So first, let's find Android Studio app where we downloaded it from the search bar. So we type in Android Studio, and we can find the application that we downloaded. Yeah, so as you can see, we found the app. So now I click Open. So now we can open the application. If you notice, a window called Import Android Studio Settings pops up. So if you've already got Android Studio installed on your computer, you can just directly transfer the settings there. But since we are going to install Android Studio for the very first time, we'll choose the Do Not Import Settings option. You follow? So I'll just press the OK button. Now here it asks if we want to share the data with Google. Now I'll choose the Don't Send option just because. You can choose whatever you want, but whatever you do, you'll see a window in the form of Android Studio Setup Wizard pops up. So now we can start the installation. So I'll just press the Next button, and here we come up to two different options: Standard Installation, Custom Installation. So you can complete the necessary installation procedures by choosing the Standard Installation from here. But I do want to show you all of the steps in the installation process. So that means I'm going to choose Custom. So here I just press the Next button again. Now on this page, it'll ask us to select the JDK, that is the Java Development Kit location. So this kit comes embedded with Android Studio. So actually, there's not a real need for the JDK installation that we did in the previous lesson. I just want to show it to you. We still want the updated JDK file to be on our computer. You follow? So if you want to use a different IDE instead of Android Studio, you must have a JDK on your computer. Now you get it. So we download the JDK and make our computer ready to write code. So that's why we choose Embedded JDK as our option here. So we can press the Next button again. And here we can choose the theme of the interface that we're going to code. There are two different options: Darkula and Light. Now, typically I prefer the Light mode, but you can always reserve that option to choose later. So I'll press Next. So on this page, we'll do the necessary procedure for the installation of the SDK, and that is the Software Development Kit. So as you can see here, we've got Android SDK Platform, Performance, and Android Virtual Device. So these are our three different options. Now, at this point, it really is worth noting that we can test the applications that we make in Android Studio on virtual devices offered to us by Android Studio. That's why I suggest you choose all of the options here. Otherwise, you may encounter some problems a little bit later on. Therefore, I'll choose all three different options, and just below, we will need to specify the SDK location. Now, I usually set these locations to be default. You can save it to any folder that you want, and I'll press the Next button again. Now on this page, for the emulator, we can set the RAM size that we're going to allocate. Now in general, we can pretty much use the size suggested, and then while your emulator is running, the size that you set here will be used from your RAM, of course. When you close the emulator, your RAM will continue to run at its previous size. So without changing anything, I'll just press Next. So this page also lists the settings that we have made so far. So if there's any setting that you want to change, you can always return to the previous page where you made the relevant settings, changing by clicking the previous button. So if you're not going to make any changes, you can confirm all of the settings, and that way we can complete the installation by clicking the Finish button. As you can see, the download starts, And just like before, this process may take a while, so I'm just going to stop the screen recording at this point, and when the installation is complete, we'll continue where we left off. All right, my friends, my installation is complete. I hope yours went well. So here I'll just press the Finish button. And as you can see, to create a new project or open an existing project in Android Studio, more precisely, this will be the first screen that we encounter every time that we open Android Studio. But in any event, we can create a new project here. So I'll choose from here the Create New Project option. So from this page, we'll choose a template for Android project that we're going to create. So first I want to have a look around at the different tabs here. So as you know, Android operating system is used not only in phones and tablets, but also in watches, televisions, and cars, and, well, many different areas. So it becomes important on which device type that you want the application to work. So you will need to choose a template suitable for the relevant device. Now, since we will develop applications for tablets and phone, well, we're going to choose the Phone and Tablet tab. And of course, there are many different templates in this tab. So Android Studio offers us some ready-made templates so that we can get faster results for the projects that we'll do. For example, if we're going to make an application about Google Maps, right? Well, we can use the template here. Of course, we'll always choose an empty template. If you notice, there is the empty activity option as well. We're also going to talk about the concept of activity a lot from now on, because in Android, the interface design is shown to the users, and the software part related to the interface design constitutes the activity. Now, those might be unfamiliar concepts right now, but we're going to talk about them until, well, forever. So we're going to explore those details in some of the upcoming lessons. Just for now, choose the empty activity option. Press the Next button, and from this page that opens, we will configure the project that we create. So in other words, we determine the name of our project and the programming language right here on this page. So let's make those necessary definitions. So I will specify the name of my project, and here, of course, you can write whatever name you want. But at the same time, the name that you write here will be the name of your application. So for now, I'm just going to write First Project. Now, the second field is the field where we're just specifying the package name of our project. So you can think of the package name as the ID of your application. So generally, project package names are created as com.anything.application name. Okay. So if you just leave this as the example, you wouldn't be able to publish your application on Google Play because Google accepts the expression example as a sample work and would not allow it to be published on Google Play. Therefore, if you do work for a company, you could always write special expressions such as company name or your own surname. So that's why for now, I'm just going to leave the example for now, because I'm not going to be publishing this application anywhere. All right, so the third part in here is the file path, where our project will be saved. So you can save your project to any folder that you want to on your computer, but notice that there are / and project name right at the end of the file path. So in other words, if you change the file path, remember to add / and your project name to the end of the new file path. Otherwise, you won't be able to save your project, okay? So that's why in the beginning, I like to choose defaults. So here in the fourth part, we'll need to choose the programming language that we will use in our project. Now, we will be building our applications using the Kotlin programming language, so that's why I choose Kotlin from here. The fifth partition is the minimum SDK partition. So in other words, from which version of Android will we want the applications that we're going to make run? And we can determine this right from this section here. So as you know, Android is constantly releasing new versions, like Android 9, 10, Android 11. So it's from this section that we can determine the minimum Android level that the applications that we will make are going to work on. For example, if we choose Android 8, well, the application that we will make will also work on Android 8, Android 9, Android 10, and Android 11. So that's why the version that you choose refers to the minimum Android version. So if you notice, when I choose any version, Android Studio tells us just below what percentage of Android devices this application will run on. So if you are going to publish your app on the Play Store, you can choose a lower Android version from this section. So of course, at this point, I also need to point out the following. Since some codes are updated with each new version of Android, choosing the lowest Android version can sometimes cause us problems. So that's why I generally choose API level 23. Of course, we can change these settings later, my friends. It's not a do or die situation right here, okay? You can choose any version, as we're just currently doing sample projects. Just want to flag that up for you. So now finally a checkbox gets created, and here we can use Android's old library, Android support. But we're not going to choose this option because we will use the Android X library. And this is the current library of Android. So that's what we'll be using in our projects, my friend, the current library of Android, this Android X library. All right, so now let's create our first project, or, well, my first project, by clicking the Finish button. So here, the creation of this first project may take a little while. It's also related to the speed of your computer. Now, you may also encounter an assistant like this when any invocation or update is made in Android Studio. So you can review this document. You can also close this window just by clicking the Assistant tab here. And on the bottom right part of the interface, we'll see an expression of the build processes of the project. So here, my friends, we don't want to take any action before we see the completion of the project, right? Otherwise, you may encounter some problems, and you don't want to do that right at the beginning. So again, just by opening the Build tab here, we can see whether the project is completed or not. All right, so when the project is completed, or if any error is encountered, you can see these processes right here in this section. The process of creating the project may take some time again, so that's why I'm just going to stop the screen recording here, and when the project is completed, we'll continue where we left off, my friends. All right? So as you can see, the project has been created. So far, we have installed Android Studio. We've created our first project. So from here, we're going to take a break. In the next lesson, we'll go over all of Android Studio's interface. See you in the next lesson. All right, hello, my friends. Now, in our previous lesson, we completed the installation of Android Studio, so you know what that means. In this lesson, we will examine the interface of Android Studio. All right, so let's get right to it. So, of course, after creating our first project, we encountered a screen like this. So then at this point, I would like to remind you once again, after making sure that your project is fully loaded in the Build section, you must perform the necessary actions. See, because if your project has not been loaded yet, you can wait for the project to load completely without taking any action. All right, so after making that little disclaimer reminder, we can now examine the interface of Android Studio. All right, so if you have a look, we can actually break down this interface into 4 different parts. So the first part is, well, this is the part where we're going to do the coding and the necessary designs for our projects. Now, if you notice, there are 2 tabs here. First of these is a main activity, and this is what we're going to use when we write code. And the second one is the XML file that we can design for our projects. Now, while developing an Android application, we first create the design of the application that we're going to make, and then we can write all the necessary coding for this design. So, in fact, this section is what we will use as the very basis of what we're going to do from here on out. So for now, it's enough to know that this is where we start. So after examining the other parts of the interface, we're going to examine this part in detail. So in other words, we'll come back to it. Now, the section here on the left is the section where the project files are located. So if you see this part differently, you can just click on the part that says Android above. So here on your screen, it might say project instead of Android. Okay, so you can choose the Android option from the pop-up that opens, and here's a little menu, and let me just talk about this a little bit. So when we create a project in Android Studio will also create many different files related to our project for us, just automatically. So that way we have the opportunity to run our project on different platforms, share it with different people, or even publish our project. So this feature is the main reason why we use IDEs like Android Studio instead of a simple text editor when coding. So if the project is selected instead of Android here, we will view all the created project files in here. Of course, this kind of creates a complex view because while developing applications, we're not actually going to be using every file that is automatically created. Therefore, for a simpler view, just make sure that the Android option is selected here. So if we examine the project directory here, a new folder has been created under a Java folder with the package name that we specified when creating the project. And just below the package folder, the Kotlin class, that is main activity, where we will do the coding, right, has been created as well. So when we develop an app, we will make our applications where we will need more than one class, yeah? So here are the Kotlin classes that we will create for this stage. Now, you may not know the concept of each of the classes right now, but don't worry. We will learn these terms in detail throughout our upcoming lessons. Now, we also talked about the design file. So where is this design file, you might ask? Well, if you look a little further down the project directory, you will see a folder named Res has been created. And this is actually the resources folder. Maybe I should call it Reese. But then I think of peanut butter cups. Okay, so this is the folder, in any event, where the design files, images, colors, writing styles, and themes related to our project are kept. So we're going to dig into these in detail too in the future. I want you to also have a look in the layout folder here. There's the design file of our application. So now if you close the main activity class and the activity main.xml file right there next to them by pressing the X sign, you can open them up again from the project directory. So we can also collapse and expand the part reserved for the project directory. For this, you can position your mouse on the line between project panel and main panel. Now notice that the cursor has changed, right? So you can expand or collapse the project panel by dragging it to the right or the left. You can also close and open your project panel completely. For that, you just press the minimize icon here. If you want to open the project panel again, you can just click on the project tab here. All right, my friends, so that's pretty much the project panel. So now we can look at the menu bar at the top of the interface. So here you can see many windows and many interfaces. From the File tab to the Help tab. Okay, so first we can examine the File tab. As you can see, there are many features in here, but we will examine the features that we will use just, for the outset. During the course, we will, of course, examine the other features as we need them. So first off, you can create a new project by using the New and New Project options here. By using the Open option, you can open up a project that you have created before. You can also close your open project by just using the Close Project option. You can use the Settings option here to make the necessary settings for Android Studio. Of course, some of our friends will be using the Macintosh OS. So we can, or you can, anyway, click on the Android Studio icon that's just to the left of the File tab and select Preferences from the pop-up menu that opens there. All right, so now let's go ahead and open up the Settings screen. Now you can search for the feature that you want to, because there's a very clever search bar here. For example, size of text in the area where we will be coding can be quite small. So I'll just enlarge the text so that you can see it better. All right, so for this, I just type font in the search bar. And as you can see, when you type font, the relevant features become available. So in order to change the necessary features, I'll first delete the text font from the search bar. Thus, the relevant fields become active. So now you can change the font from the font section here. You can also enlarge the size of text from the size section just below. So I'm going to set the font size to 18. Press OK or Apply at the bottom right. And that applies the changes. So as you can see, the text can be more readable now. Of course, you don't have to make it that big. I'm just doing it in a way so that you can see it easier. But now I want to look at another feature. I'll go back to the search bar and type in theme. All right, so using this feature, you can change the interface theme to dark mode or light mode, depending on your preference. All right, so let's examine the SDK section and finish the settings. So I'm writing SDK into the search bar. Here you can see SDK. And there are also 3 tabs just below. So the first is SDK Platforms. If there were any problems during the installation, we could download the SDK that we need from here. As you can see, here's the installed statement. If you happen to have an other statement, you should tick the checkbox here and press the Apply button. And that way you just reinstall SDK. Just installs what's necessary. So I open up the second tab, SDK Tools. As you can see, there are 4 tools installed here. If you're missing any of these, if it's not installed or if it needs to be updated, just go ahead and tick this checkbox here and press the Apply button. Now, of course, some of our friends are going to be using AMD processors, so you will need to select the Android Emulator Hypervisor driver for AMD processors. Such an option that you can check here. Now, I actually should mention that we are going to test the different applications that we develop on virtual devices that Android offers to us. These are typically called emulators, right? So these emulators use virtualization technology. Therefore, virtualization technology must be active on your computer. Otherwise, you wouldn't be able to install the emulator. Now, I shared the steps that you need to do to activate the virtualization feature of your computer as an information note in our next lessons, but I just want to give you a heads up. This feature is usually active on computers that already have an Intel processor. Okay, but computers with AMD processors, we might have to change it manually. So just keep that in mind. So yeah, let's continue. We can also install Google Play services and USB driver tools here. That way, if you want to test your projects on your Android device instead of on an emulator, you can always install these tools. So for this, I'll just tick the checkbox and click on Apply. Click OK. And accept the necessary licensing agreements. So when you click the Next button, the necessary installation process begins. And of course, my friends, if you encounter any errors during the installation process, if the necessary tools are not properly installed, well, you can just go back to the Settings section and complete your installation. All right, so now that the download process is over, I'll just press the Finish button. And sure enough, my friends, that completes this edition of the Settings Show. Now let's have a look at some of these other tabs that we're going to use. So I want to show you the View tab. So by using this tab, you can toggle many views in the interface. For example, by using the Tool Window tab here, we can open and close the tools on the edges of the interface. And again, from the Appearance section here, you can choose which tools that you want to appear on the interface. For example, if we select the toolbar from here, the Save the Project, Open an Existing Project, or Reload the Project icons will appear on the interface. The View tab is, well, generally like this, so I don't think I have to do anything more here, because we're actually not going to use these other tabs here much, but, you know, you never know. So you can open those and close those in your own time. But I just wanted to let you know where they are. So finally, though, I do want to show you the Build tab here, because sometimes after the project is created, well, you might get an error or two. So in that case, you may need to rebuild your project. So to rebuild the project, you can just use the Rebuild Project tab here, and it'll allow you to rebuild your project. There may be some other situations where you need to restart your project, so you can always restart the project by selecting the Invalidate Caches and Restart, which is the option here under the File tab. And but don't worry, I'm going to explain this section in the tutorial where we will install the emulator. All right, so don't get too carried away. So why don't we go ahead and examine a little bit of the design area. So for this, I want to open the activity main.xml file. If you want to, we can close the project panel and you can see it more easily. All right, so that looks better. So we're only looking at the design space now, right? So we can get the design space a little closer, a little bit broader, a little bit fuller. And we can examine this design area by breaking it down into 4 different sections. The first is this palette section, upper left, okay? Here are the components that we're going to use while we're designing. For example, we'll access many components from here, such as buttons, text views that we can write text into, and image view components that we can add images to. And of course, we'll be using them, and I'll be showing you some of the details in the following lessons. So this is just a brief overview with some general info. So we can actually move any of the components here to the design area just by dragging and dropping. Also, if you click on the eye icon here and select the Show System UI option, you'll get a real Android phone screen. So you can make your designs that much better. There are also a couple of views in the design area. We don't really use the blue area. We'll only be doing our designing in the white area. So in order to edit this, I can click on the Select Design Surface icon here. And then when you select Design from here, only the white design area appears. And if you select the Blueprint option, only the blue design area will appear. And then if you select both, Both sections will appear in the design area. But since we are doing our designs using just the white area, I will just choose the design option here. All right, so I'm going to delete the text view component where the hello world text is written. This you can click on the component and press the delete key on your keyboard. Now, if you press Control and Z, you can always undo your actions. Or after selecting the component, you can just right-click with the mouse and select the delete option. So I couldn't exactly select the component. Did you see that? So I'll zoom in on the area and select it. Yeah, okay, see. Got to be a little closer sometimes. So finally, you can select and delete the component from the component tree section, which is the second part of the design area. That was a smooth segue, huh? So again, to add components to the design area, you can just drag and drop the component that you choose from the palette section to the component tree section. Now, the component tree is where the components that we use in the design area are located for your design use. And we can select the components from the design area. We can also select them from the component tree, change their required properties. We can also change the properties of the components from the attribute section located on the far right. Now, to change any feature of a component, for example, the text size or the color, after selecting the component from the design area or the component tree, we can find the feature that we want right here from the attribute section and make any changes that we want to. And of course, we'll be doing all of these processes in detail later on, but now you know where they're located. So I do want to tell you this, though. If you notice, the design file is actually a .xml file. So in other words, an XML code is actually created for all the components that we'll be using while designing. And here are all the properties of the components as well. For example, to add a button to the design area, we can add the button from the palette by dragging and dropping, or we could create it by writing the XML code. And for that, we can just open the split or code tabs on the upper right corner. And if we open the code tab, we will only see the section where the XML codes are written. So if we open the split section, we can see both XML and design. So if you open up the design tab, you can only see the design area. And then if you notice, the XML codes for the button that we created are automatically generated. Cool. So in our next lessons, we will learn how to create the components using XML. But my friends, you can see Android Studio's interface is pretty easy and fun to navigate around. I've shown you most of the parts that we're going to be using frequently throughout this course, so we will get into the details in the future. All right, my friends, so we've made all the necessary preparations to develop our applications using Kotlin. So now we can just, well, now that we're all set up, we can just focus on learning the Kotlin programming language. So the way that's going to go is teach you Kotlin, then we'll develop Android applications using Kotlin. So therefore, I will install the emulator after we hit up some of this Kotlin language, okay? So we'll take a short break here, and I'll see you in the next video. Well, hello, my friends. So in the previous lessons, we completed the JDK installation. We completed Android Studio installation. We had a tour of the interface of Android Studio. So in other words, we are set, ready, and primed, okay, to develop Android applications using this Kotlin programming language. So now why don't we just get started? So we'll go to Android Studio and do a few necessary actions. If you remember, we already have a project called First Project, which we created while installing Android Studio, and we have it left over from the previous lesson. So our screen looked like this. So before we delve into Kotlin, I want to show you how to close an open project in Android Studio and then create a new project. So to close an existing project in Android Studio, my friends, we can use the File tab in the upper left corner of the screen. And after clicking on the File tab, we can select the Close Project option from here. And in this case, our project in Android Studio will be closed. So as you see, we encounter a pop-up here when you first start Android Studio. So if you notice, the first project that we created earlier appears here. So in this area, the projects that we have created before appear so that we can open any project just by clicking on them. It's convenient. So if a project that we have created before is not actually displayed in this area, we can just select the Open Existing Project option to open that project. All right, so after choosing that, we'll need to access the file containing the project that we want to open. And at this stage, you know where you save your projects, right? So my projects are saved in the Android Studio project folder by default. That's why I don't change that. So if we select First Project from here and press the OK button, we can open up the project. And of course, to create a new project, because that's what we're setting out to do, I just want to choose the Create New Project option here. And I select the Empty Activity option in the Phone and Tablet tab and press Next. And from this page, we will configure the project that we will create, my friends. So I'll write First Kotlin Program in the name of the project. You can, of course, write whatever you want. We can change the package name, or it can stay like this. If you want to, you can write your surname instead of the example here. So I'll write Tech Mania here. And then this will be where the file gets saved, and I'm not going to change that. All right, so our programming language will be Kotlin. And the minimum SDK level I would set to 23. All right, so after making these adjustments, I'll just press the Finish button and wait for the project to be created. Cool, so when you create the project for the first time, it may take a few minutes, all right? So we don't really get to take any action here before the project is completely created. All right, because if you start messing around, you might get some errors. All right, my friends, so let's check it out from the Build tab. As you can see, our project has been successfully created. So now we can take a few wonderfully necessary actions. Before developing Android applications, I want to show you how this Kotlin language works, right? Some of the basic coding in Kotlin. So we're not going to actually use this space here right now, my friends, and we will not make any designs either. But I already pre-warned you, so there you go. So why is this? Well, we're not going to develop an application right now because I really do want to show you the basics of Kotlin and some of the most frequently used commands as well. So after we learn Kotlin really, really well, and you will learn it quickly, then we can develop, well, at a much swifter pace, perhaps, really great Android applications by using all of the information that you have learned up to that point. So, my friends, I've explained enough. That's enough legal disclaimer. Let's move on to learning Kotlin, okay? So, for that, we need to create a new Kotlin file, and we'll do some of the necessary operations in this file. So we'll create a new file in Kotlin as follows. Select the package name in the project directory and right-click. Select New Kotlin Class /file, and that's from the option window that opens. So as you can see, a window pops up, and from this window we choose File option, not the class. So after selecting the File option, we need to give this file a name. Now, in this lesson, because it's the first time, we will print an expression, namely Hello World, to the console using Kotlin. So therefore, I will set the name of the file that I will create to be hello world. Now, if you notice, I always capitalize the first letters of the file that we create here, right? I don't leave any spaces in between two words. Now, since the word hello world, or words, I suppose, are two different words, we capitalize the first letters of each, right? So this is the general protocol. Now, another spelling is hello_world, but your first word should usually be capital. All right, so now I'll just correct that again. So after typing hello world, press the enter key on the keyboard. And as you can see, a new Kotlin file gets created. Cool, so now we will print hello world to the console using this Kotlin file. And here I would like to point out that normally in order to perform an operation in the Java programming language, well, there must be at least one class and at least one main function in the class. But you don't need a class in Kotlin. So it's not mandatory here. Therefore, instead of creating a class here, we will first create a function. And of course, you might be a little more unfamiliar with these concepts like class and function, but don't worry about that. We'll get into those weeds later in our next lessons. So currently, you only need to specify that there must be at least one main function in order to run a program in Kotlin. Because when you run the program, the Java virtual machine has to know where to run the code. So therefore, we will create the main function here. So how is the main function created? Well, here I just write fun, okay, to represent the function, and press enter on the keyboard. So if you pay close attention, when you type in fun, Android Studio offers us some options. And from here, you can select the fun option and press enter. Cool, so next we need to give a name to the function that we've created. Now, since this function is our main function, we will write main here. Now notice when we write main here, we can understand that this is an executable function with the green triangle. All right. So now we can move on to creating the function. So after typing fun main, open a parenthesis here, and we'll need to specify the parameter, that is the argument of this function in parentheses. And we'll specify the argument as follows. We write args, that is argument, in the parentheses. And I put a colon and write array in here and select the array option. Then when we press the less than key on the keyboard, we create a tag. That is chevrons. Now, in addition to this, we'll need to specify the type of this directory in the tag. So I'll just write string here. And finally, we need to specify the scope of this function. So we use curly braces for this. And by passing in the enter key, I'll move to the next line when I press the Alt F7 keys on the keyboard. Curly braces appear, just like magic. So I press enter again. So in this way, we have created our main function. So let me just show you again and explain it. So notice here that the function starts with the expression fun. The name of this function is main. Also, this main function takes a parameter. And this parameter is an array. The type of this array is string. And finally, we specify the scope of the main function with curly braces. So, if we're going to print something to the console, we have to write it between these two curly braces, you see? So to put that more precisely, when we run the program, the codes that we write in this main function will run. So if you want to, let's go ahead and print hello world to the console now. So how would you print an expression of the console in this Kotlin programming language example that I'm showing you? So for this, we'll just use the system.out.print function in Java. But in Kotlin, we will only use the print function for this. So after you write the print function, you can write an expression that you want to show on the console in parentheses. Of course, since we're going to print a hello world, that is a string expression, I write hello world between double quotation marks, my friend. Yeah, so actually when we run the program, we will see the hello world on the console. Now, of course, you might be thinking, well, why did we put double quotation marks like that? This is actually a syntax form of string expression. So in our lessons, you will be seeing this a lot, and we will see variable types such as strings and integers. But for now, that's enough to know. So how can we print an expression to the console using this Kotlin programming language? Well, let's now run this program. And here's how we run the program in Kotlin. Select the file that we want to run from the project directory, right-click with a mouse, select the file named Run Hello World from here. And when you choose as a console screen, we'll open at the bottom of Android Studio, and we can see the output of the program on this screen. And while the program is running, I would like to underline the following once again. We are currently learning to print an expression on the screen using this Kotlin programming language. So what I want you to do is, first of all, if you just watch the lesson and complete the steps that I've done, by the time you know a little bit more about Kotlin, you will certainly understand these operations. Well, what's the expression? Like the back of your hand? You'll know it like the back of your hand. I don't spend too much time looking at the back of my hand, but you get the point. So my friends, you can see now that the program works. We see hello world on the console. Okay, so we printed hello world on the screen using Kotlin. So let's go over what we did. So since we've only learned a little bit and we're not developing any Android applications yet, we did create a new Kotlin file. We will continue our operations through this Kotlin file. And also, if you want to run a bit of code in Kotlin programming language, we need at least one function, all right? The name of this function that we created is the main function. So we created the main function as follows. First, we needed to specify that it is a function. So that's why we write fun here. And we write the name of the function, namely main. And we need to define an argument to it in parentheses. And we define it like this. Args represents the argument. After writing a colon, we create an array of the type string. We specify the scope of this function using curly braces. So we specify the area, okay, that it will cover. Then finally, we can write the codes that we want inside these two curly braces. And we printed hello world to the console. And then how do we actually print? Well, we print this with the print function. So we put it in double quotation marks inside the parentheses. Hello world is a string. And in order to run the program, we choose our file from the project directory, right-click with the mouse, and choose the Run Hello World option. All right, so that prints hello world on the console. All right, my friends, so that's it for this. We'll take a short break here. And then in our next lesson, we're going to, well, get into some more of the details of this Kotlin language. I hope you're enjoying it so far, and I'll see you in the next lesson. Hello, everyone. So in this lesson, we are starting the main fundamentals of this Kotlin programming language, which is why you signed up, right? So one of them is variables. So in this section, we're going to first learn what is a variable, but then we're going to learn how to declare and initialize variables. You see, that way we'll be learning types of variables because there are mutable variables and immutable variables, and everything's variable, all right? So Let's start off with this variable question. So if you think of variables like a container or a box, which holds a value for you during the life of your particular Kotlin program, right? So we'll keep it relevant. So what it means is once you create a variable, you can reserve some space in memory. So every variable is assigned a data type, and then it holds the quantity of value or whatever the heck you're putting in there. I'll show you why I say that. Because there are two different steps to use a variable in a program, all right? Declaration and initialization. So in order to declare a variable, you must specify the variable and give a unique name to the variable. So in our example, we'll declare the variable to be age. Now, in order to initialize a variable, you've got to assign it a valid value according to its data type. So we use the equal sign, means that the value on the right side of the equal sign will be saved into the variable on the left side. Follow? So in our example, we assign the value 37 to the variable age. All right, cool. So I want to tell you, though, that this Kotlin programming language has rules and conventions for naming variables. So while declaring variables, please note that Kotlin is a case-sensitive programming language. And that means that upper or lowercase letters in your Kotlin programs matter. They matter a whole lot. So this variable age that here consists of all lowercase letters is way different from a variable age, which would be the first letter capital and the rest lowercase. So to continue with these naming conventions and rules, a variable name can begin with a letter or an underline mark. If you declare a one-word variable name, use lowercase all letters. This isn't necessarily mandatory, but it is conventional wisdom. Also, if you declare a variable name having more than one word, use all lowercase letters for the first word and capitalize the first letter of the next word. All right? So now let's get into the types of variables. So we have two different types of variables in Kotlin. Mutable variables are represented by var. Immutable variables are represented as val. So basically, val and var are both used to declare a variable, but var is like a general variable and can be assigned multiple times. This is also known as the mutable variable in Kotlin, whereas val is a constant variable. How's that? And cannot be assigned multiple times and can be initialized only one single time. So that's why this is known as the immutable variable in Kotlin, all right? Val, the immutable variable in Kotlin. Sounds like a hero. But we're not doing a complex game right now, so we'll postpone that idea. All right, so enough about variables. Why don't we just move on to Android Studio and do a little bit of an exercise. This way you'll get used to everything about it. So first, we'll create a new Kotlin file. For this, all I have to do is right-click on the package folder in the project directory and select New Kotlin File, and follow the options. So I'm specifying the name of this file to be variables. So when you press Enter on the keyboard, the Kotlin file is created. Now remember, we needed at least one main method in Kotlin. So first, let's create the main method. But this time I want to show you how to create the main method in an easier way. All right, so I'll just type in main here. From here, I'll select the main A option and press Enter. And what do you see here? We created the main method right away. All right, so now we can get to coding. All right, so we'll declare three variables. First, I'll write var A and assign a value of 10. Second, B and assign the value 20. And lastly, C and assign A plus B. Okay, so let's print variable C on the screen just by using the print method. Now, Android Studio has a quick shortcut for you to write this method, so just type sout and then hit enter on the keyboard. So this is named code completion. So it allows us to quickly complete statements in our code. We can use this combination in, well, all of the other parts of this program: variables, functions, classes, etc. Also, notice that in our previous lesson, we used only the print function when printing hello world to the console. But here we're using the println function. So this means that after we print the desired expression of the console, the cursor then automatically moves to the next line. That is, when we print more than one result to the console using the println method, the results are listed one below the other. All right, very cool. Okay, so let's run the code. For this, right-click on the variable Kotlin file and select Run. And the result will print 30 in the console. Also, we can directly write A plus B to the output. Okay, so let's run it again. And the result is correct. Very good. So let's look at some of the naming rules for variables. So we're going to study this via variable age. Var age is valid. So also, I would like to mention the comment line in Kotlin here. So in this Kotlin programming language, if you use a double slash, all the statements you type from that point on through to the end of the line are perceived to be comments. That is, it's not perceived as code. Comment lines are not taken into account when compiling your code, right? If you want to use more than one line as a comment line, well, you can write whatever you want between /* and / this time. So just by using this feature, you can take notes on the margins of code here. All right, let's continue from where we left off. Var _ age is valid. Var age 3 is valid. But var a space GE is invalid, right? And 3 age is invalid. All right, because a variable name cannot contain a space, as well as you can't begin a variable name beginning with a number. All right, so let's comment out our code here. So I'll use the / and asterisk marks for the comment line, as there are multiple lines. All right, cool. So now I want to show you the difference between var and val. So first off, I'll create a variable of type var named age and assign the value 20. All right. So now I'll assign the value 10 to the age variable in the next line. And now let's print the age variable to the console. So what do you think is going to be written on the console? You must have an idea, right? 10 or 20? Cool. So those who said 10, you got it. Because the type of the age variable is var. And we can change the value of this variable, type var. We first transferred the value 20 to the age variable. Then we transfer the value 10 in the next line. And as a result, the value of the age variable became 10. And we printed 10 to the console. So now let's create a variable of the type val. So I'm typing val year, and I'll assign the value 2020 to the year, So let's try to change the value of the year variable in the next line. So I will write year equals 2019. Yeah, so as you can see, Android Studio throws an error because when we position the cursor over the word year, we see the warning, val cannot be reassigned. All right, so in other words, we wouldn't be able to pass a second variable to a variable of the type val. All right, so what's going on here? When do we need the val and when do we need the var? Well, while developing an application, we may want the value of some variables to remain the same. For example, if you're going to make a calculator and you're going to use the value pi, and you're going to specify pi to be 3 all over this application, well, in this case, you could create a variable of the type val named pi. All right. Or we could think of it like this. Let's say you've developed an application that retrieves some data from the internet. So in this case, the data retrieved from the internet may vary from time to time. So in that case, you would definitely specify the type of the variable that you would define to be var. All right, so that's the concept of var and val. I hope you understood them, because now you really just need to play with them and write them in and see how you do. But now you know what you need to do in order to create a variable. All right, so in our next lesson, we're going to learn about data types. So I'm going to see you there in the next video. All right, well, hello, my friends. So in this lesson, we're going to go over some data types. The data type basically defines the values that a variable can take. Based on the data type of a variable, the operating system allocates memory and then decides what can be stored in the reserved memory. So therefore, by assigning different data types to variables, you could store integers, decimals, or characters as these variables. So in Kotlin, we generally define the data type of the variable to use it, and we cannot assign incompatible data types. Otherwise, the compiler will give us an error. So let's have a look at this diagram. Now, there are 5 basic data types available in Kotlin. First one is Boolean data types. The second is character data types. And this is represented in Kotlin as char. Now, the third is a numbers data type, and there are 2 different number variables. So the first is integer variables, and the second one is floating point variables. There are 4 different integer variables, and these are byte, short, int, and long variables from smallest to largest. Floating point variables are also divided into 2. These are float and double. And then finally, we'll get to string variables, and these represent textual expressions in arrays, and these can hold more than one value in themselves. All right, so let's have a look at the different Kotlin data types in this table. The byte data type is an 8-bit signed 2's complement integer. The byte data type is useful for saving memory in large arrays. It has a minimum value of -128 and a maximum value of 127 inclusive. So the default value of the byte is 0. The short data type is a 16-bit signed 2's complement integer. Similar to byte, uses short to save memory in large arrays in situations where the memory savings actually matters. Now, this has a minimum value of -32,768 and a maximum value of 32,767 inclusive. Also, the default value of short is 0. The int data type is a 32-bit signed 2's complement integer, which has a minimum value of -2 to the 31st and a maximum value of 2 to the 31st minus 1. The long data type is a 64-bit 2's complement integer. The sign long has a minimum value of 2 to the 63rd and a maximum value of 2 to the 63rd minus 1. So you use this data type when you need a range of values wider than those provided by int. Float data type is a single precision 32-bit floating point. So if you need to save memory in large arrays of floating point numbers, definitely use a float instead of a double. The double data type is a double precision 64-bit floating point. For decimal values, this data type is generally the default choice. Boolean data type will represent only one bit of information, either true or false. The char data type is a single 16-bit Unicode character. All right, so when defining data types in Kotlin, we've got to first specify the variable type. Then we write the name of the variable that you're going to create. So in this example, the name of the variable is age. Then we have to specify the data type after putting in a colon. So in this example, the data type is integer. Yeah? Okay. So after the equal sign, we've got to pass the value of the variable. So in this example, I have passed the value 20 to the age variable of the type integer. Okay? So that's how we define a variable in Kotlin. All right, so that's marvelous information that hopefully you didn't know before about using variables with Kotlin. So we'll move on to Android Studio and do a little bit of an exercise. Cool, so we first got to create a new Kotlin file. So I'll just right-click on the package folder in the project directory and select New Kotlin File. Now, I'm specifying the name of this file as data types. So when you press enter on the keyboard, our Kotlin file is created, okay? So of course you remember that we need at least one main method in Kotlin. First, let's create the main method. So we'll start with data types, var Boolean equals true. So this Boolean type has two possible values, either true or false, yeah. Var char equals R. Char type declares a character. Var byte equals 12. So this byte type can have values, right, between minus 128 right the way through 127. Var short equals minus 356. So the short type can have values from negative 32,767 right the way through 32,767. Var int equals 43,543. Int type is generally used for numeric values. So now let's declare variable f with the long data type. The long type is used for large values, as I'm sure you're remembering. So this capital L is a specific suffix for the long type. Another variable g with float data type, and float type is used for large values with single precision. And capital F is the specific suffix for float type. Now another variable h with double data type. So double data type is used for large values with double precision. So there we go. We've defined the variables. We've set their initial values. So now let's print the values of these variables on the console just by using the println function. So first I will print the a variable to the console. Now I'll copy this line of code by pressing Ctrl-C on the keyboard at the same time, paste it 7 times by pressing Ctrl and V on the keyboard at the same time. And let's change the variable name from A to H. All right, so now let's run the code. Let's see the results in the console. Very cool, my friends. So we're going to end this lesson here, and next time we meet, we will learn type conversion and type casting. All right, so I'll see you in the next video. All right, hello, my friends. So in our previous lesson, we learned the data types that are used in Kotlin. But we haven't learned any string and array data types yet. Well, we're going to learn more about this data type in our next lessons. But in this lesson, we got to first learn how to convert between data types. Wait, what? Why would we need to convert data types? Why do we need data conversion? Okay, before you ask too many questions, let's say that you're going to develop a calculator application, and you'll divide the one integer number entered by the user by another integer number entered by the user. But the result of the operation may not always be an integer. So in this case, if you don't convert the result to a double or a float, you're going to lose data. So if it doesn't quite make sense, let me just make it concrete with an example. So the user wants to divide the number 25 by 2. All right, so in this case, the result's going to be 12.5. If you define the result variable as an integer rather than a double or a float, well, in Kotlin, it's going to round it to 12. So in this case, we could use some type conversion. So how do we do that? Okay, you got me convinced. Let's do it. Well, but first, before we jump in, there's a number of different methods used in Kotlin for this. That's why we're taking so long to delve in. So I'll have a look at these methods now. To convert any data type to byte type, the toByte method is used. To convert any data type to short, the toShort method is used. To convert any data type to the integer type, the toInt method is used. You following? So to convert any data type to the long type, yes, the toLong method is used. And any data type to the float type, the toFloat method is used. And to convert any data type to double, the toDouble method is used. Now, of course, there is another thing that you got to pay attention to. So you remember I shared the sizes of data types in the previous lesson? So let me just remind you once again here, the largest of the data types is double, then float, then long, then integer, then short, then byte. So if you convert a small value to a large value, there's not going to be a problem. In other words, if you convert a byte type to a double type, well, you will not experience any data loss. However, if you convert a large value to a small value, you may indeed incur data loss. For example, if you convert a variable of the type double to type integer, you will most definitely lose data. All right, my friends, so that's a little bit of inside info about this type conversion, but why don't we put it to good use and let's open up Android Studio and do some practice. So first I want to create a new Kotlin file. Now you could continue on the previous Kotlin file, but since I'm going to share these examples with you at the end of the section, I just want each topic to be a separate file. So you can follow the code according to the subject order. And, some people just like it that way. So I will set the file's name as type conversion. So now let's create the main method. So first of all, for your convenience, I will write out the type conversion methods in the comment line. toByte, toShort, toInt, toLong, toFloat, and finally toDouble. All right, so now I can create a variable of the byte type here. So I'm typing var x colon bytes equals 128. As you can see, Android Studio gives a warning. So why? Anyone? Anyone? All right. Let me just tell you real quickly. A variable of the type byte could have a maximum value of 127. Therefore, we wouldn't be able to give this variable a value of 128 or more. So I'll just fix this and type in 127 here. Okay, so now let's create a variable of the type integer and pass the value of the variable x. All right, I'm typing var y colon integer equal, here, all right, x dot to int. See how that converts the x value of the type byte to type integer, all thanks to the toInt method, and it transfers it to the variable y. Now let's create a variable of the type double and pass the value of the variable y. So I'm typing var z colon double. I'm typing equals y dot to double. And that way we convert the y value of the type integer into double thanks to the method of type to double and transferred it to the variable z. So now we can print the x, y, and z variables to the console. So we will print the x value first. So I'll just type in print in x. Now I can copy and paste this line twice. And I'll write y here and z here. Now let's run our code. And as you can see on the console screen, the value of the x and y variables is printed as 127. The value of the z variable is 127.0. So actually what we did here was type conversion from small to large. So we didn't lose any data. But I do want to show you type conversion from largest to smallest. Let's see what happens. First, I'll just convert these lines of code into the command line. Now I'll create a variable of type double, typing var a colon double equals 132.32. Just below the line, I'm typing var b colon integer equals a dot to int. Last but not least, I'm typing var c colon byte equals b dot to byte. And now let's print these values to the console. So I'm copying and pasting the above print in methods here. But instead of x, y, and z, I'll write a, b, and c. All right, so now let's run our code. So what you see here is the value of A is 132.32, while the value of B is only 132. So the value of C is a very different result, friends. That's because we try to convert a large number into a small number, and what did I tell you? We've got some data loss. So yeah, you've got to be forward thinking here and take it into consideration in future applications, because it could turn around and bite you where you don't want it to bite you. All right, my friends? So that is type conversion in Kotlin. We'll take a short break here, and then in the next lesson, we're going to learn about that string data type that I promised you about. All right? So I want to see you in the next one. Well, hello there, my friends. So in this lesson, we will learn string data types. Now, by string in Kotlin, we mean a set of characters, such as the word hello or the phrase, Kotlin is funny. When passing a value to a variable of string data type, we write the value to be passed between double quotation marks. So if you remember from before, we had a data type called char in our data types lesson. This char data type could only store one character, okay? But what if we want to pass an expression with more than one character to a variable? That's why we need to use the variable type called string. Now, in our example, it represents a string object in memory consisting of hello characters, right? So characters in a string are identified by their index number. In hello, in fact, the leftmost character H is at index 0. Next character E is at index 1, and then it continues numerically up from there. So the string class provides many useful methods to perform string operations. So have a look at the table. The length method returns the length of a string. It has no parameters. The equals method compares the string with a specified string and returns true if two string objects contain the same contents, else false. Follow? The isEmpty method returns true if the given string has 0 as its length. If the length of the string is non-zero, then it returns false. The plus method adds a string expression enclosed in parentheses to the end of another desired string expression. Lowercase method returns a string in lowercase. Uppercase method returns a string in uppercase. Now the trim method removes spaces at the beginning and end of the word. Cool. All right, so we'll move over to Android Studio and warm up with some practice. So before creating a new Kotlin file, let's just close these files that we created in the previous lessons, because now I want to create a new Kotlin file. I'll specify the name of this file to be string data type. All right, so we'll create a main method, and then I'll create a variable of type string. So I'm writing var a:\string here. After typing equals, you can type in any expression that you want to between double quotation marks. So I'm just typing in hello Kotlin. And now let's print the variable a to the console. So I'm writing print in a, and now let's run the code. Okay, so as you see, the console says hello Kotlin. And now I want to show you how we can concatenate two string variables. So for this, I will create a new variable of the type string. And here I write var b:\string. I write language between double quotes. Now let's print the variables a and b to the screen together. So I'm typing print in here. And write a plus b in parentheses. So the plus sign that we use here will concatenate two strings. So now we can run the application and let's have a look. And yeah, sure enough, it says hello Kotlin language on the console. But notice here that there's no space between the two words, right? Because this concatenation method adds the second word directly to the end of the first word. So how do you put a space between the two words? I'm glad you asked. I will show you. Since space will actually be of a type string, we can use double quotes and leave one space. So in parentheses, a plus double quotes, I leave a space, plus b. Let's run our code one more time. And there you have it. There is now a space between the words hello Kotlin and language. So what we did here was concatenated two different string expressions. So now let's print two variables of type string and integer to the console. Yeah, so for this, I will create a new variable of the type integer. I write var age:\int and pass the value 25. Now let's print your age is 25 on the console. So after typing print in, I write your age is, in parentheses, between the double quotation marks, and after leaving one space, I write plus age. Ah, see. Now let's run our code. So as you can see, it says your age is 25 on the console. Cool, I could see that you were getting it right as we were going along. So we're going to be using this a lot, okay? Very, very, very often. So we can learn some of the methods that are used in the string class. All right, so first of all, I'll just convert the codes that I wrote here into a comment line. Now we'll create a new string variable, var x : string equals, and I'm writing Kotlin. So now let's use the length method first. Now, if you remember, the length method gives us the size of a string variable. So now I want x.length on a bottom line. Of course, this method will give us the length of the Kotlin word in the integer type. So if you press the Control and Space keys on the keyboard after you move the cursor to the right of the length method, well, you can open a suggestion window here. What do you know? So you see, therefore, it would be more logical to pass this value to a variable of type integer. That's why I'm typing var I : int equals here. Thus, the length of the Kotlin word will be calculated with the length method and then passed to the variable I of the type integer. Then finally, we can print this I variable to the console. So I'm writing print in parentheses, and between double quotation marks, I write length of Kotlin equals, and I write plus I. Cool, so now let's run the code. And as you can see, the length of the Kotlin word on the console screen is right here. That is, how many characters it consists of. So that's how you use the length method. Now let's have a look at how you use the equals method. So what I'll do is convert the codes here to the comment line, but I will not delete the x variable. We can use that. So I'm typing x.equals here. I'm typing in parentheses between double quotes in Java. So if the value of the variable x is equal to the Java word, it'll give us the value true. If not, it will give us the value false. So as a result, it's going to return a Boolean value, right? Therefore, I will pass this result to a variable of type Boolean. So here I write var b : Boolean. Now let's print variable b to the console. So I write b in parentheses. Okay, so now let's run and test it out. So as you can see, it prints the false statement in the console. So now we can compare two different string expressions using the equals method. All right, so yes, there's more. Let's have a look at the isEmpty method. So this method also checks whether a value is passed to a string variable, and if not, it returns false. I'm also converting the codes here into comments. And now I'm typing print in here, and I'll write x.isEmpty in parentheses. This way we can print the true or false value directly to the console. And as you can see, we saw the false value in the console because the variable x is not empty and the value Kotlin is passed into it. So now let's have a look at the plus method. You can concatenate two string type variables using the plus method, right? So I'm typing print in right here, writing x.plus in parentheses, and we should write an expression of type string inside these parentheses. So I'm typing language here. Cool, so now let's run our code. And as you can see, the Kotlin language is written to the console. So now let's have a look at the lowercase and uppercase methods. These methods also convert all letters in a string type expression to lowercase or uppercase. So why don't we test it out? So here I'm typing print in. I write x dot lowercase inside the parentheses. Now I'm going to the bottom line. After typing print in, I write x dot uppercase. And also, to separate these two lines of code, we can apply a method like this. So I'm typing print in right here, and I'm doing a partition by pressing the asterisk key right on the keyboard between the double quotes and parentheses. So you can use this method when you're not going to print multiple data to the console. So now let's run our code, and you can see, first, all letters of the word Kotlin are printed in lowercase, and then all letters are capitalized. And see, both expressions are separated by asterisks. Okay, so finally we'll learn the trim method, and we can wrap this lesson up. Of course, you remember, trim method was also for removing spaces at the beginning and at the end of string expressions. For example, let's say you made an application that asks the user for username and password. Well, the user may have accidentally put a space at the beginning or the end of the username. People do that. Yeah, right. So in this case, if you do not delete this space while storing the user may encounter an error the next time that they log into the application, won't be able to log in, and then they'll go crazy. Okay, so in these cases, the trim method is used. So let's now reinforce this issue with an example. So here I'll just create a new variable of the type string, and I'm writing var t:\string. After double quotes, I put 3 spaces and type Android. So after typing Android, I'll leave 3 spaces again. Now let's print the variables x and t together to the console. First, I will print without using the trim method. So I'll write x plus t in parentheses. Just the bottom line this time, I will use a trim method, so here I'm typing x plus t dot trim. All right, so now let's run our code. And look at that. As you can see, it was first printed with spaces, and then it was printed after it removed the spaces in between. What do you think of that? Some kind of magic? I don't think so. That's Kotlin. All right, so my friends, that is how you deal with string variable types. So we'll take a short break here, and in our next lesson, we're going to learn about the array variable type. All right, there's a lot packed into arrays. So I'll see you next time. All right, so hello, my friends. Of course, in our previous lesson, we learned about the string data type. So in this lesson, we're going to learn about arrays. Now, I'm sure you remember when we were talking about data types, we said that there is also an array data type. So just what are these arrays and what are they used for? Well, arrays are actually objects that hold multiple data of the same type together. So it's very useful in solving problems involving many variables, as it can store the same type of data within itself. All right, so I'll tell you what, let me just show you an example, all right? So let's say that you store the names, ages, and addresses of employees in a company in a database. This is where you keep all of this information. So consider that there are perhaps 1,000 workers working at this company. So in other words, there's going to be 1,000 names, 1,000 ages, addresses, all registered in the database. All right, so 1,000 is just a small round number, but it's huge, okay? So let's say that you want to know the name of all the different workers. So in this case, you could create a variable that you will pass each name into and then act on these variables. But what's that going to do? Well, first of all, it involves a lot of work. It's actually quite difficult because in this case, you would need to create 1,000 variables. So that's why, in this case, we would use an array. So in other words, instead of creating 1,000 variables, we could create one array and get the names of 1,000 workers from the database. Does that make it a little clearer? So now let's see how we can actually create an array. So first of all, we do want to determine what are we going to call this array. And we specify the elements of our array using the arrayOf method. So if you examine the example here, we've got an array called age. This array has 7 elements of integer data type. So each element in an array is also represented by an index. In other words, the first element of the array is actually the element whose index number is 0. The 5th element, well, of course it's an awesome movie, but the 5th element of the array is the element with the index number of 4. So you follow? The 7th element of the index is the element with the index number of 6. So that is, the index number starts from 0. The final index number is 1 less than the number of the elements of the array. All right? So that's enough of that information. Let's move on to Android Studio and practice it. You'll pick it up really quickly. So first I want to create a new Kotlin file. I'll just specify the name to be arrays. Okay, so now let's create the main method. Now we can create an array called age. So I'm typing var age equals. After typing arrayOf, we can write the elements of the array in parentheses. So we also use commas to separate elements from each other. As you can see, we have an array here of 3 elements called age. Now this 0th index of this array has 1, okay? The first index has 2. The second index has 3. All right, so let's print these elements to the console. I'll write S out and press enter. So we'll print the first element of the array. So I'll write the first element of the array equals between double quotation marks. After the plus sign, write the name of the array and write the age. Then I write the index number of the element that we want to show in the console, which in this case is 0, inside these square brackets. All right, so now let's print the second and third elements in a similar way. What I'll do is I'll copy and paste this line of code twice. And then we can break in and do some editing. So I'll write 1 inside the brackets. So that will be the second element of the array. In fact, to get the element of the array at any index, we can use the get method rather than writing it this way. So let me show you that real quick. In other words, after typing the name of the array, if you write .get and write the index number in parentheses, you can learn the elements of the array. So yeah, there's no difference between these two spellings, actually. You can use either one. So I'm also writing 2 here. So it'll be the third element of the array. All right, so now let's run our code. And there you go. You can see that we've printed all the elements of the array to the console. And that's good. So now let's create an array of the type string. So in here, I'll just write var cars equals. After typing the arrayOf, I'll write the elements of the array in parentheses. So let's let the first element be Mercedes. Now notice that I always write string expressions between double quotation marks. So we'll let the second element be BMW. And let's make the third element Opel. And now let's print these elements to the console. So for that, what I'll do is copy and paste the above methods here. And let's replace age with cars. Because, you know, our array is called cars. Now, also, in order to not mix with the elements of the above arrays, I'm going to make a partition here. I will divide by using the dash in parentheses. All right? That looks good, so now we can run our code. And there you see, my friends, we have printed the elements of the age array and the elements of the cars array to the console. So now we can look at some other operations that we can do in arrays. First of all, let's try to replace the third element of the cars array. So in other words, when we first created the array, we set the third element of the array as opal. Now, we're going to try to make it Ford. So we're going to use the set method for this process. So after typing the name of the array, if you put a dot, you will see a number of options provided to us by the code editor. And when we write set here, it's going to ask us for two parameters. First parameter is the index number of the element that we want to change. The second parameter is the new value of the element. So, for the first parameter, I'll just type in 2 because the index number of this opal element is 2. And I write Ford as the new value. So now let's print the elements of the array again. I'll copy the methods from here, paste them in here, and now let's run the code. And look at that. As you can see, the third element of the cars array was opal, and after changing it using the set method, it became Ford. Now let's see, I also want to show you how we can find out the size of arrays. Because sometimes you can develop some applications by retrieving data from the internet or, a database. And in these cases, you might not know the size of the arrays initially. And believe me, you do want to find out. So for this, we always use the size method. So I'll show you, if you write cars.size here, well, you can find out the size of the cars array. And now let's print it to the console. So I'm cutting this out and putting it in parentheses, right? And before it, between double quotes, I write size of cars array. And I'll put the plus sign in to combine these two expressions. All right, so let's run the code. So as you see, we saw the number 3 on the console. So finally, I want to show you one more thing. And that is, okay, so when you want to create an array using the arrayOf method, well, the elements of the array can be of different data types. So we don't have to specify the elements of the array just as integers or just as strings or just doubles or something, right? So in other words, the types of elements in the array can be different. So I will reinforce this idea with an example. So here, look, I am going to create an array called cars and age. So after writing the arrayOf method, I'll write Mercedes as a first element. I'll write 5 as a second element, opal as a third element, and 10 as a fourth element in parentheses. So now let's print the elements of this array onto the console. So I'm copying the print in methods here and pasting them here. Now I'm going to copy and paste one more time because the array consists of 4 elements. All right, so now let's organize our methods a little bit. So I'm typing fourth here, and I am now correcting the array's name to cars and age. Okay, so finally I'll write 3 here. Now let's run the code. Okay, so as you can see, we have printed the elements of the array to the console. So you see how just by doing it this way, you can also create an array using different types of data types. All right, so that's pretty cool, my friends. So far, we have learned how to create an array, how to access the elements of the array, how to change the element in any index, and how to find out the number of elements in the array itself. Just when you thought we were wrapping up, I do want to take you one step further. Now, I want you to notice that when we create an array, we have determined its elements from the very beginning. Well, what do you think? Could we add an element to an array that already exists? Or perhaps if we can, how do we do that? Well, let's have a look. So let's take, for example, the latest cars and age array that we created. So this is an array consisting of 4 elements. So why don't we try to add the 5th element to this array? If you haven't seen it, you've got to. Anyway, so first I'll write the name of the array. Now, if you remember when we were presented with a number of options after putting a dot, we just kind of went ahead with it, right? But I want you to see if you can just, just watch along with me or do it along with me, depending upon your skill level. So let's just scroll through and see if there's a method like add or put. So no, we can't actually see such a method. So what do you think? Could we do that with a set method? Well, let's try. All right, so after writing the set here, let's write the index number and the element that I will add in parentheses. I'm writing 4 as the index because, well, the index number of the 5th element will be 4. So let's write 20 as the 5th element. Now, if you want to, go ahead and run the application and test it out. But as you can see, you're going to get an error. So this error is called array index out of bounds exception. So we tried to exceed the limits of the array, but when we did that, we encountered an error. So what do you think we should do if we want to add an element to an array later and not encounter an error? Well, in this case, we could use array lists. So in other words, it is possible to work a little bit more flexibly by using array lists. So why don't we just break here for just a short time, and we'll learn about array lists in the next video. Cool? So I'll see you then. Well, hello, my friends. So in our previous lesson, we introduced the concept of arrays, right? So in this lesson, we're going to talk about array lists. So I'm sure you remember after we created the array, we couldn't add a new element to the array that we created. But there is a method for this. We need array lists. So why don't we just go ahead and have a look at how to create these array lists? So we can create the array list in 2 different ways, it turns out. Well, the first is very similar to the method that we created in the first or previous lesson here. All right, so after specifying the array name, we could write array list of on the right side of the equals. So we also need to specify the type of array here. We also need to write the array type between the chevrons. All right, so that's the first method. But in the second method, after defining the name of the array, we write array list to the right of the equals. And again, we write the type of the array between the chevron sign. So the difference between these 2 methods is that in the first method, you can specify the elements of the array while you're defining the array, or you can add them later. But in the second method, you can add elements to the array only after having created the array. Okay? So in other words, here, the choice is up to you. You can choose any of these 2 methods depending on the application that you're going to make. So now let's see how we can add elements to array lists, since we're doing it right here. We can now use the add method for this. Of course, we could use the add method in 2 different ways. Full of options we have here. So in the first method, we can just write the element that we want to add. In this case, it always adds the element that we want to add at the end of the array. In our example here, the last element of the index, that is the 3rd index numbered element, would be 20. Or we could specify the index number of the element that we will add, right? So in this case, we would need to write two parameters in parentheses. The first would be the index number, and the second is the element that we will add. Now we can also delete any element from array lists, and for this we could use a remove method. Again, it's possible to use the remove method in two different ways. So in the first method, we can write the element itself. In the second method, we can remove the element from the array by specifying its index number. All right, so that's all you need to know about array lists. Why don't we go ahead and move on over to Android Studio and put it into practice. So I just want to create a new Kotlin file. And here I'll specify the name of this file to be ArrayList. Now let's create our main method. So first I will create an array list of type integer. And I'm writing var age equals ArrayList. We'll also specify the type of array between the chevron marks here. So here I'll write int, and finally I'll put in parentheses. So we've defined an array list named age and type integer. Now let's create the elements of this array. So on the next line, I will write age.add. I write 10 in parentheses. And just by doing that, we added an element to the array list named age. Now let's add the second element. So this time I'm going to add the index number by specifying it. So I'm writing age.add, and I'll write 1 in parentheses. So this represents the index number, yeah? Since, of course, the number 10 we just added is the first element, the index number was 0. This will be the second element, so the index number must be 1. Now, let's write the value of the second element. So I'm typing 15 in here, and thus we have determined the first two elements of the array list named age. So why don't we go ahead and add one more element and print these elements to the console. So I'm writing in age.add. I'll write 20 in parentheses. Now let's print these elements to the console. So I'll type sout and press enter. And if you remember, this method was creating the print in method quite quickly. So I'm writing the first element of age array list in double quotation marks inside the parentheses. And after typing the plus sign, I'll write age and open square brackets. I'll write 0 here. So in other words, we print the element of the age array with the 0 index number to the console. Now I can copy and paste this line twice. So I'll type second here. I'll write third here. Cool. So now let's print the second and third elements. Now, here I want to show you something a little different writing styles, okay? So to print the second element of the console, I'll write age.get, and I write 1 in parentheses. And there's really no difference between this type of writing and the way that we're going to write it in the next line. You can use both. So now let's print the third element to the console. But here I want to talk about a writing style that I haven't yet mentioned. So I'm going to show you how to write any line of code in a string expression. Now, if you've noticed, whatever we write inside the double quotation marks here looks exactly the same in the console. So you could say that it's not detected to be code. So if I cut the age2 expression here and write it in double quotes here, it will appear exactly like this on the console screen. So we wouldn't be able to learn the third element of the array. So what could we do for this expression so that it would be perceived as code? Do you know? Take a guess. Or no, that's why you're taking this course. Okay, well, I'll continue. But what would happen if you put a $sign at the beginning of an expression that you want to be treated as a code in double quotation marks? And then enclose that expression in curly brackets. The expression after the $sign will be treated as code. Now, we don't use this spelling very often. It is useful to know. So now let's run and test our code. So as you can see, we've printed 3 elements of the age array list to the console. Now, if you want to use the remove method, I wonder if you remember, we could remove any element of the array from the array list with a remove method. Yeah. For example, let's just remove the second element of the array, 15, from the array. So for this, I'll write age.remove. And if you use the remove method, you must directly write the element itself in parentheses. So if you use the remove at method, then you must write the index number of the array you want to remove in parentheses. So I'm using the remove method right now. You can go and test the other method yourself, but I want to show you this. So write 15 in parentheses. Of course, when we delete the second element of the array from the array, the third element of the array, 20, will now become the second element of the array. So now, let's first print the size of the array to the console. So for this, I can write age.size in parentheses. Now let's print the first and second elements of the array. For this, I can copy and paste the above lines of code here. Now also, before running the code, let's convert these lines of code to the comment line. All right, so now we can run the code, and we should be able to see the numbers 2, 10, and 20 on the console. And as you can see, we have printed the size of the array, its first and second elements, right here to the console. So now, let's try this. We'll create an array using the ArrayListOf statement. And this time, we're going to create an array of type string. So I'm writing var cars equals array list of. The type of array will be string. And now we can specify the first 2 elements of the array here. So I'll write opal in parentheses as the first element. Second element, I'm going to write BMW. Now we can add the third element of the array using the add method. So here I'll write cars.add. I'll write Ford in parentheses. And now let's print the elements of the array to the console. So for this, I'll copy and paste the lines of code that I wrote above. And I should write cars instead of age here, because the name of our array is cars. Yeah? Good catch. Finally, let's run and test our code. So as you can see, we printed Opel, BMW, and Ford on the console. And as you can see, guys, we can create array list using both methods, right? That's cool. Now, I do want to show you one more thing, and then we'll wrap this lesson out, okay? So if you remember, in our array lesson, we created an array containing both string and integer expressions. And yes, this is also possible with array lists, my friends. So in other words, there may be different data types in the array that you want to create. Totally doable. But for this, my friends, you will need to define the type of the array as any. All right, so let me just show you a quick example. So here I'm writing var myMixArrayList equals. So after writing an array list, I set the type of the array to any. Now let's add an element to the array. Let the first element be of type string. So here I write myMixArrayList.add. I write Ford in parentheses. Let the second element be of the type integer. So I write myMixArrayList.add. I'll write 5 in parentheses. And we'll make the third element be of the type double. I'll write myMixArrayList.add. I'm writing 2.5 in parentheses. And let's make the fourth element be of the type Boolean. So I'll write myMixArrayList.add. I write false in parentheses. Now the fifth and final element will be of the type char. So I'll write myMixArrayList.add. I write K in single quotes in parentheses. So now let's quickly print these statements to the console and see what we get. So I'm writing myMixArrayList square bracket 0 inside the bracket. Now let's copy this line and paste it 4 times. Now let's edit inside the square bracket. Finally, all right, 4. All right, so now let's run and test our code. And as you can see, we have printed the elements of the array list, which consists of different data types, right here to the console. All right, my friends, so that's how you use array lists. I'll tell you, we're going to be using array lists a lot, just a heads up, when we're doing our Android applications. So get used to it, and hopefully you get the logic. Of course, we're only showing you just the bare bones of it. So yeah, I might have heard a couple of snores out there, not sure. But when you start developing your Android apps using this information you've learned, oh boy, you're going to see how it makes it such a joy. Truly. All right, so just be a little patient in the beginning and learn it all, and we'll just have a short break here. Want to see you in the next lesson, which starts in the next video. See you then. Well, hello, my friends. So in our previous lesson, we learned about array lists. So in this lesson, we're going to learn about set, which derives from the collections class. Actually, you're going to think that it's used a lot like array lists. There is one very important difference. In array lists, you can use the same element more than once in the array. But in sets, only one of the same element is stored. So even if you try to add the same element more than once, in fact, if you notice in our example here, the array that we created using the array list of has 4 elements, and the number 2, it's used twice. So in this case, when we print the size of the array to the console, we get the number 4, and we can see the last element of the array as 2. But when we create the same array using the set of, well, we get the size of the array to be 3, and we can see the last element of the array as 3. You see? So in other words, only one of the 2 elements written twice is taken into account. The other element is not even noticed. So if you want to, let's go ahead and open up Android Studio and have a little practice. So first I want to create a new Kotlin file, and I'll make the name of this file to be collections set. All right, so we'll create our main method. And first I will create an array using the array list of method. So I'm writing var my set array. I'm writing equal array list of, and I'll write any as a type of array, because this array will consist of different types of elements. So let's let the first element be Kotlin of the type string. Second element, let's make it 2 of the type integer, and we'll make the third element 2.5 of the type double, and we'll make the fourth element k of type char. Now, of course, we've got to have a fifth element, and this will be true of the type Boolean. So now let's use the Kotlin element of the string type once more. All right, so in other words, we're going to let the 6th element of the array be Kotlin of the type string. So So now I will print two different values to the console. So the first one will be the size of the array. So here I'll type S out and press enter. So I write my set array.size in parentheses. Now, if you remember, we were able to learn the size of the arrays using the size method, right? So let's print the last element of the array. So for this, I want to show you a different method here. So after typing S out and pressing enter, I'll just write my set array in parentheses. I write .last. The last method allows us to access a last element of the array. All right, so let's run our code now. And we should see the number 6 and the Kotlin expression in the console. And what do you know? Here in the console, you can observe the size of the array, it's 6, and the last element of the array is Kotlin. So in other words, we can add the same element more than once to the array using the array list of, right? So now let's create the same array using set of. So I'm going to copy and paste the same code that I wrote. And now let's turn these lines of code into the comment line. So here I'm just going to write set of instead of array list of. And after typing set, I choose the set of expression here, and to replace the set of with the array list of expression here, we can just press the tab key instead of enter on the keyboard. You see how that works? So we can easily write set of instead of array list of. All right, so now let's run our code now. We should see 5 and true in the console, and as you can see, although we defined 6 elements in the array, we observe the size of the array to be 5 in the console. And of course, the last element in the array is the true expression, not Kotlin. Because even if we use the same element more than once in the arrays we create using set of, this gets ignored. All right, so that is how you can use set of collection. Right, so what we'll do is have a short break here, and in our next lesson, we're going to learn about the map collection. All right, so I'll see you on the other side. Well, hello, my friends. So we learned the set in our previous lesson. So that means in this lesson, we're going to learn the map. The feature that distinguishes map from other collections is that we can store elements in the array as key value pairs. Huh? Yeah. So let's examine our example on the screen. So after specifying the name of the array, we write map of to the right of the equal sign. Between the chevron marks, we need to write 2 different data types. So the first data type will be the type of key that represents the element we will add to the array. And the second data type will be the type of element that we want to add to the array. So in our example here, the key's type is string. The element's type is integer. All right, so we now need to write the key and value parameters within parentheses. So in this example, we've got 2 elements. The key of the first element is David, and its value is 20. The key of the second element is Ronaldo, and that value would be 25. So now let's see how to print the elements of an array created with map of to the console. So in our example, to print the value 20 to the console, we will need to use the David key. And of course, similarly, to print the value 25 to the screen, we'll need to use the Ronaldo key. Cool? So now that you have the lowdown about map, why don't we open up Android Studio and practice it a little bit. So first, I'll create a Kotlin file, brand new, specify the name, collections map. So now let's create the main method. So I set the name of the array to be age, write the map of, between the chevron marks, I must first write the key's data type. So here I'm writing string. So now I've got to determine the data type of the element that I will add to the array. So here I can write int. And of course, you can specify any data type that you want here. But now let's try to add the elements of the array inside the parentheses. So David will be the key of the first element. David's age will be 20. We associate the key and value pair with each other using the to statement. All right? So this is how you can store people's ages, just like this example. You specify contact names as keys. You can also specify people's ages as values. So now let's add the second element. So I'm typing Ronaldo as a key, and Ronaldo's age will be 25. Okay, so we've added the ages of David and Ronaldo to the array as a key value pair. Now, let's print these elements to the console. I'll type as out and press enter. And I'll write the age of David in parentheses between double quotes. And after I put the plus sign in, I type age and open square brackets. We should write the key here as well. That's why I'm writing David here as a string expression. Now let's print Ronaldo's age on the console. So I can copy and paste this line of code. I'm typing Ronaldo here. And I'm correcting the key here to be Ronaldo. All right, so now let's run our code. Right, so as you can see, we have printed the ages of David and Ronaldo right here to the console. All right, my friends, so that's how map works. But I do want to talk to you about one more thing. Notice that we added the elements of the array while defining the array. So, can we add an element to the array later, or can we remove any element of the array from the array? Let's have a look at it now. So when I type age.add or age.put here, no method appears because set and map collections are also divided by mutable and immutable, right? The map of that we use here is actually an immutable collection. So that is, you have to specify the elements of the array at the beginning. And then after you create the array, you cannot make any changes to the array. If you do want to make changes to the array later, well, you really ought to prefer mutable collections. Okay? So here, I want to show you an example. So I'll just copy the same code that I wrote and pasting it here. I'll change the name of the directory to mutable age. Also, we should write mutable map of instead of map of here. So now after typing mutable, I'll select mutable map of from here and press the tab key on the keyboard. And now we can add a third element to this array, but this time I will do this addition in a bottom line. So I'm typing mutable age.put in here. In parentheses, firstly, we will write the key and then the element. So I'm writing Buffon. No, it's not a French name. But anyway, Buffon's age here will be 30. So let's print this to the console, see what we get. So I'm copying and pasting the print method here. I'm writing Buffon here. And again, I'll write Buffon as the key. Now, before running the code, let's put a string expression at the beginning of both outputs. So here, I'll write immutable map of. I can copy this and paste it here. And then here I'll write mutable map of. All right, so now let's run our code. Cool, so as you can see, we got the age of Buffin, which we added later to the mutable age array as null in the console. Because when printing Buffin's age, we use the array named age again. But we have to write the mutable age array here. All right, you follow? So let's fix this right now. Okay, so we can now run our codes. And as you can see, we have printed the element we added later to the mutable age array to the console. So you can also print to the console using the get method. So for this, you must write get here, and you must also write the key in parentheses. All right, so let's run this code. Now you can also run your code by pressing the green triangle here. Have you done that yet? And as you can see, there's no difference between the two methods. Same operations we apply to the set of, which we learned in the previous lesson. All right, what do you think of that, my friends? So we've learned quite a bit about arrays and collections, but before we wrap this lesson, I would like to mention one more thing. I want you to notice that we have used a print method for each element while printing the elements of all the arrays that we have created so far to the console. So what if our array consists of 1,000 elements? Should we write 1,000 print methods? Now, have you been thinking ahead? I think perhaps some of you have already posed this question in your head. So let me just answer. No, of course not, right? In Kotlin, there is a way to make this process easier. Loops. Yeah, so we can print elements of an array to the console very simply just by using loops. Now, before we jump into loops, I do want to give you some intel about operators first, okay? And then we'll learn about loops. So we're going to break here. See you in the next video. Hello, friends. All right, so in this video, we're going to learn about arithmetic operators in the Kotlin programming language. So Kotlin provides operators that perform addition, subtraction, multiplication, division, and remainder. So these are basic mathematical operations that you know and love, right? Plus is the additive operator. It adds two operands. Minus is subtraction operator. It subtracts right operand from the left. Asterisk is the multiplication operator. It multiplies two operands. Forward slash is the division operator. It divides left operand by the right one. Type of division result is float by default. Percent is the remainder operator. So this symbol might look new to you. It divides one operand by another, and it returns the remainder as its result. All right? So let's dive in a little bit deeper to understand these arithmetic operators with some examples. So we'll open up Android Studio. Now first I'm going to create a new Kotlin file. Right-click on the package name, select the New Kotlin File option. Now after selecting the File option here, I'm going to determine the file name to be Arithmetic Operators. Cool, so I'll hit Enter. So now I've got to create the main method. Right, main, select the main option here, hit Enter. So this main method has been created. So now we've got to declare three variables with double types. First, number 1, and assign 8.4. Second, number 2, assign 4.2. And last, result with initial value 0.0. So first, assign number 1 plus number 2 to the variable result. And then let's show the result value by using the print in method. inside the double quotation marks, I'll write number 1 plus number 2 after the plus sign. I write the result. But the plus sign we use here and the plus sign we use to add number 1 and number 2, you see how they're different from each other. Here we use the plus sign to concatenate two different string expressions, like I mentioned earlier in our previous lesson. So here's to mathematically sum two different values. Now we may run the program after all these operations. So let's copy the code, change the operator with a subtraction operator, and I'll put the minus sign in here, and change the operator in the print method. I'll put the minus sign in here too, all right? Okay, so let's make changes for multiplication. So I'll put in an asterisk in here, and I'll put the asterisk sign here. And we can make changes for division. So I'll put the division sign here, put the division sign here. And then finally, why don't we make changes again for the remainder operator? All right, so that's all for now. Let's run the code, and let's watch the console. Number 1 plus number 2 equals 12.6. Number 1 minus number 2 equals 4.2. Number 1 multiplied by number 2 equals 35.28. Number 1 divided by number 2 equals 2.0. Number 1% number 2 equals 0.0. So the remainder is 0. All right, so there you have it, my friends. Arithmetic operators used in Kotlin work out to be just like that. That's all. So we'll take a short break here, and then in the next video, we're going to learn about assignment operators. All right? Hello, friends. So in this lesson, we're going to learn assignment operators as promised. So assignment operators happen to be the most common operators. An assignment operator assigns the value on its right to the operand on its left. So to give you an example, the equal sign is a simple assign operator. It assigns values from the right side operands to the left side operand. Plus and equal is add and assignment operator. So it adds the right operand to the left operand and assigns the result to the left operand. Minus and equal is subtract and assignment operator. So it subtracts right operand from left operand and assigns a result to the left operand. Asterisk and equal is multiply and assignment operator. It'll multiply the right operand with the left operand and assign the result to the left operand. Forward slash and equal is divide and assignment operator. It divides left operand with the right operand and assigns a result to the left operand. What about percent and equal? Modulus and assignment operator. So it takes modulus using two operands and assigns a result to the left operand. So now let's do up some examples with some assignment operators in Android Studio. After all, that's why you're here. So first, I'm going to create a new Kotlin file. Right-click on the package name, select the New Kotlin File option, and after selecting the File option here, I determine the file name Assignment Operators. All right? Just hit Enter. And now I've got to create a main method, so I'll write main and select the main A option here and hit Enter. Thus, the main method has been created. All right, so now we can start to code. So let's declare three variables with integer type. First, x and assign 20. Second, y and assign 15. And last up, z with the initial value 0. Now let's assign x plus y to variable z. And this is the simple assignment operator, right? So let's print the result by using the print method. Now we may run the program after all the operations, right? So what we'll do is we'll copy the code, change the code with a z plus equals x. This is add and assignment operator, so it is the same as z equals z plus x. Now we'll change the code with z plus equals x in the print method. So let's copy the code and change the code with z minus equals x. So this is the subtract and assignment operator, so it is the same as z equals z minus x. So we can change the code with z minus equals x in the print method. So now let's copy the code again and change the code with z asterisk equals x. And this is the multiply and assignment operator. And of course, it's the same as z equals z multiplied by x. And we'll copy the code again and change the code with z divide equals x. So this is the divide and assignment operator. And of course, it's the same as z equals z divide x. And now let's copy the code again and change the code with z% equals x. So this is modulus and assignment editor. It's the same as z equals z% x. That should do it, so let's run the code and watch it in the console. X plus y equals 35, so the value of z is 35. The value of x is 20. The z equals z plus x equals 55. Z equals z minus x is 35. Z equals z multiply x is 700. Z equals z divide x is 35. Z equals z% x is 15, which means that the remainder is 15. All right, so there you go, my friends. In Kotlin, you can use these assignment operators. So we'll take a short break here. And next up, in the next video, we're going to learn unary operators. All right? See you then. All right, well, hello, my friends. So in this lesson, we're going to talk about the unary operator. The unary operators require only one operand. So they perform various operations, such as incrementing and de-incrementing a value by 1, negating an expression, or inverting the value of a Boolean. So you can see how important that would be. So let's have a look at these operations, shall we? Well, there's the plus. So this is the unary plus operator. Now it's used for giving positive values, natch. But it's only used when deliberately converting a negative value to a positive. And this is the unary minus operator. And it's used for negating the values. Double negatives, yeah. So the increment operator, a plus plus, it increments the value by 1. Minus minus, the decrement operator, it decrements a value by 1. And the exclamation mark. So this is a logical complement operator. It inverts the value of a Boolean. So why don't I show you a few examples of unary operators in Android Studio, and you'll see how useful they really are. So first off, I want to create a new Kotlin file. So I'll right-click on the package name and select the new Kotlin file option. After selecting the file option here, I just determine the file name as unary operators. Hit enter. Okay, so now I've got to create the main method. Right main and select the main A option here, hit enter, and that way the main method gets created. All right, so why don't we start the code? Let's declare two variables. First off, a number with double type and assign 7.6. Second is check with Boolean type and assign true. And now in the first print method, we're going to use the unary plus operator. So let's copy the print method and paste it 4 times. And for the second print method, we can use the unary minus operator. Third print method, we'll use the increment operator. Fourth print method, we'll use the decrement operator. And for the last print method, we'll use the logical complement operator. All right, so that's that. Let's run the code. Now remember that the value of the number variable was 7.6. So what do you see in the console? Plus number equals 7.6, so there's no change. Minus number equals minus 7.6, so it inverts the sign of a number variable. Plus number equals 8.6, so it has incremented the value by 1. Minus number equals 7.6, decrements the value by 1. Not is check equals false. So the first value of is check was true, remember? So this inverts the value of a Boolean. Now in Kotlin, we can also use a plus and minus operator as both prefix and suffix. However, there is a significant difference while using increment and decrement operators for prefixes and suffixes. So let me just show you by example. So I want to declare a variable result with the double type and assign 4.7 to it. Now in the first print method, we use the increment operator as a suffix and write result plus. And in the second method, we'll write only result. And for the third method, let's use the increment operator as a prefix and write plus result. And for the last print method, we'll write only the result again. All right, so that's all that. Let's run the code and see the results in the console. See, so when the first print is executed, the original value is evaluated first. The result is increased only after that. First, the result variable, that is 4.7, printed to the console, and afterwards increased the result value. So we got 4.7 as an output. Also, the result value is 5.7 now. So when the second print gets executed, the increased value, 5.7, is printed. However, when the third print is executed, the result is increased by 1 first before it's printed on the console, yeah? So the value of 5.7 increases by 1, and the new value of the result variable becomes 6.7. You follow them? So then the value of the result variable is printed to the console like that. And of course, when the last print is executed, 6.7 gets printed. All right, so very quickly and very simply, those are the unary operators that we use in Kotlin. So we'll take a short break here, and in the next video, we're going to learn about equality and relational operators. Okay, so I'll see you then. All right, hello, my friends. So in this lesson, we're going to talk about the equality and relational operators. So the equality and relational operators determine if one operand is greater than, less than, equal to, or not equal to another operand, right? So let's have a look at how they work. Equal. So this operator checks to see if the values of two operands are equal or not. If yes, then the condition becomes true. Here is the exclamation mark and equal. So this operator checks to see if the values of two operands are equal or not, and if the values are not equal, then the condition becomes true. Greater than sign. So this operator will check to see if the value of the left operand is greater than the value of the right operand, and if yes, then the condition becomes true. And the less than sign So this operator checks if the value of the left operand is less than the value of the right operand, and then if yes, the condition becomes true. Now here's the greater than or equal sign. So this operator checks to see if the value of the left operand is greater than or equal to the value of the right operand, and if yes, then the condition becomes true. And less than or equals, well, this operator checks if the value of the left operand is less than or equal to the value of the right operand, and if yes, then the condition becomes true. All right, so that's the basic outlay. Why don't we set up some examples using equality and relational operators in Android Studio? So what do we first do? Create a new Kotlin file. So I'll right-click on the package name, select the new Kotlin file option. After selecting the file option here, I'll determine the file name. And I'm going to call it equality operators. So I'll hit enter. And now I create the main method. So I write main, select the main A option here and hit enter. All right, so there's our main method created. All righty then, let's start to code. So let's declare two variables with int type. Firstly, A and assign 2. Second, B and assign 5. So in the first print method, we use the equal to operator, A equal to B. So let's copy the print method and paste it 5 times. Okay, so in the second print method, we can use the not equal to operator in the parenthesis, A not equal to B. Third print method, we'll use the greater than operator, A greater than B. In the fourth print method, we use the greater than or equal to operator, A greater or equal to B. In the fifth print method, we'll use the less than operator, A less than B. In the last print method, we'll use the less than or equal to operator, A less than or equal to B. All right, so that wraps that. So let's run the code and see what we get on the console. A equal to B is evaluated false. A not equal to B is evaluated to true. A greater than B is evaluated to false. A greater than or equal to B is evaluated to false. A less than B is evaluated to true. A less than or equal to B evaluated to true. So let's change the value of a variable A to 5. So now A equals 5 and B equals 5. Why don't we run the code again and compare the results? A equal to B, evaluated to be true. A not equal to B, evaluated to false. A greater than B, evaluated to false. A greater than or equal to B, evaluated to true. A less than B is evaluated to false. A less than or equal to B is evaluated to true. All right, so what do you think now, my friends? That is equality and relational operators that we use in Kotlin. All right, so before we play around with that anymore, I want to take a short break because in our next video, we're going to talk about conditional operators. All right, so I'll see you then. Well, hello, everyone. All right, so now it's time to talk about the conditional operator. So conditional operators are used, of course, for checking multiple conditions together. So let's try to understand conditional operators and how they function in Kotlin. So the conditional AND operator. This operator is represented by the symbol double ampersand. All right. So in this operation, the result is true if both operands are true. Now this operator doesn't check the second condition if the first condition is false. Makes sense, right? So it only checks the second condition if the first one is true. Then we have conditional OR operator. So this operator is represented by this symbol. It's called a double pipe. So in this operation, the result is true if either of the operands happen to be true. So this operator doesn't check the second condition if the first condition is true. It checks the second condition only if the first one is false. All right, so why don't we do some examples with conditional operators in Android Studio, and you'll see how we can use them to our benefit. All right, so you recognize this. I'll first create a new Kotlin file. Right-click on the package name, select the New Kotlin File option. After selecting the file option here, I'll determine the file name, and let's call it Conditional Operators. Enter key, and now I must create the main method. So I'll write main. Select the main A option here, and hit Enter. And that creates our main method. Okay, so let's start to code. We'll declare 3 variables with int type. Firstly, number 1, assign 5. Second, number 2, and assign 8. And last, number 3, and assign 12, okay? Okay, so let's declare a variable result with a Boolean type. The default value for a Boolean will be false. So here we're going to use the conditional AND operator and assign the result to the variable result. So if number 1 is greater than number 2 and number 3 is greater than number 1, then the result is true, else the result is false. So in order to get the result true in the conditional AND operator, all Boolean expressions must be true. Sorry, I didn't mean to shout. All right, so let's print the result value by using the print method. All right, so let's run the code. So you can see in the console the result equals false because number 1 is not greater than number 2. Okay, so we use the conditional OR operator and assign the result to the variable result. If number 1 is greater than number 2 or number 3 is greater than number 2, then the result is true, else the result is false. So in order to get the result true in the conditional OR operator, well, at least one expression must be true. Okay, so now let's run the code. And you see it in the console, the result equals true because number 3 is greater than number 2. All right, so that's how you use conditional operators in Kotlin. So we'll take a short break here, and then in the next video, we're going to deal with operator precedence. Yes, it just gets deeper, folks, but it gets a whole lot more fun too. So I'll see you in the next one. All right, hello, my friends. So in this lesson, I promised you that we were going to learn about the operator precedence. It really is important, though, to know Kotlin interprets the symbols that you use in order to perform specific operations and in what order it's going to interpret them. All right, otherwise we could just write an application with one result in mind and receive an entirely different result. All right, so as you can see in the table, the priority column is most important because it defines the strict order which Kotlin interprets as symbols displayed in the operator column, okay? Let me highlight strict order. Anyway, an operator higher in the table always takes precedence over an operator that's lower in the table. Now, there is a very important point in this part. If you want to change the order in which an expression is evaluated, you'll have to use parentheses. So in fact, any part of an expression enclosed in parentheses is evaluated first. Ah, you knew there was a trick waiting for you. All right. So let's make a few examples with conditional operators in Android Studio. So first I want to create a new Kotlin file. So I'll right-click on the package name, select the new Kotlin file option. After selecting the file option here, I'll name the file and we'll call it operator precedence. So after I hit the enter key, now I've got to create the main method. I'll write main, select main A option here, hit enter. Okay, so there's our main method. So here I want to declare a variable result with integer type and assign 5 plus 2 multiply 4. Okay, so let's print the result value by using the print method. We'll run the code. And as you can see, the result is 13, not 28. Uh-huh. Yeah, because the precedence of the multiplication operator is higher than the additive operator. See, I'm not fooling around. So here, multiplication is performed before adding, and that means the result value is 13. All right, so if you did see that one coming, let's do another example. So let's assign in the parentheses 5 plus 2 and multiply 4 to the variable result. Copy the print method and run the code. Now the result's 28. So here the expression enclosed in parentheses is evaluated first, just like I promised. And you see that the multiplication is done. Okay, so first 5 plus 2 equals 7 is done, and 7 is then multiplied by 4, and the result equals 28. Now, you ready for a new example with unary operator precedence? Yeah, so let's declare 4 variables with an integer type. First, x, assign 8. Secondly, y, and assign 4. Third, z, assign 2. And the last, sum, assign 0. So let's assign x plus minus minus y plus minus minus z to the variable sum. And we'll copy the print method. Cool, so now let's run the code. And as you see, the result is 12 because the operator precedence of the unary operator is higher than the additive operator. Things to keep in mind, eh? Yeah, you got room in there, don't worry. All right, so the operator precedence used in Kotlin works like this all the time. So we'll take a short break here, and next time we're going to talk about the range 2 operator. So I'll see you in the next video. All right, hello, my friends. So in this lesson, we're going to talk about the range 2 method and the in operator that gets used with this method. All right, so we're starting to have a little fun with Kotlin. And this range 2 method is used for easy identification of numbers or characters within a specified range. For example, instead of making 10 different definitions for numbers from 1 to 10, we could make a single definition using the range 2 method. Or instead of making separate definitions for all letters from the letter A to the letter Z, we could do this with a single definition just by using the range 2 method. Okay, so why don't we have a look at the range 2 statement? So, as with most things, there's a couple of different ways that we can use the range 2 method. So in the first case, after defining the variable, we must write the initial value of the range that we're going to define. Makes sense? Then we have to use the range2 method. And then finally, we must write the ending value of the range that we are defining in parentheses. Now, for the second case, we'll need to use 2 dots next to each other instead of the range2 method. But of course, you can use either of these 2 methods. They both are very handy, and they both work the same way. Well, they work in different ways, but you'll see what I mean. All right, so remember earlier I mentioned the in operator? So the in operator is also used with a range2 method, but by using the in operator, you can find out if a desired value is in the range that you specify. So if you have a look at the example here, we passed all letters from A to Z into the variable named myCharRange, okay? And also pay attention to this. The letters A and Z are included in this range. All right. Okay, so let's find out if the letter K is in this range just by using the in operator. So if the letter K exists in this range, the variable myChar is true. If not, it'll be false. All right, so that's the quick and dirty of the range2 operation. So let's just move on to Android Studio, and you'll see how to use it in practice. So first, I'll create a Kotlin file. Right-click on the package name, select the new Kotlin file option. And after selecting the file option here, I'll determine the file name. We're going to call it range. After hitting the Enter key, I've got to create the main method. So I write main, select the main A option here, hit Enter, and thusly, the main method gets created. Okay, so let's create a variable called myCharRange. Let's transfer the letters from the letter A to the letter J to this variable. So I'll write A between single quotation marks. So for this example, I'm going to use the range2 method. And you can do this by using 2 dots next to each other if you want. I'm going to write J in parentheses, and again in single quotation marks. Now, of course, the reason we use single quotes here is because the char data type likes it that way. That's the way you use the char data type. What are you looking at me for? So if you are going to perform an integer data type operation, for example, if you're going to transfer a range from 1 to 10, for instance, you do not need to use single quotes. You must write 1 for the start value and 10 for the end value. All right? Yeah, you get it. So now let's define a variable called myChar. So what we're going to do is check to see if the letter K is in the myCharRange variable that we defined in the previous line. So for this, we need to use the in operator. So I'm typing K in myCharRange here. The variable myChar will be true if this range contains the letter K, otherwise false. Now let's print the myChar variable to the console. I type S out, press Enter, and I'll write myCharRange has K in parentheses between double quotes and myChar after the plus sign. Now let's run the code. Expected result would be seeing our value false in the console. And there you have it. There is the value false in the console. Because there is no letter K between the letters A through J, right? Anyway, now let's change the ending value of the range and make it K. And run the code again. Okay, so as you see, there is now a true value on the console. All right, so that is how the range2 method and using the in operator get used in Kotlin. Now, I didn't show you in this particular example, but we will be using them mostly in the for loop operations. But we're not going to get to those until a little bit later. But in any event, you'll see how it actually reinforces your knowledge rapidly. All right, so we're going to take a short break here. I want to see in the next video because we've got a lot to do. Yeah, because now the fun's going to begin. So I'll see you in the next video. Well, hello, my friends. So in this video, we're going to learn how to enter data into the console and get the data entered by the user. All right, so far we've learned fundamentally different information about Kotlin, and we've only seen the output from the console. However, we can have the user enter some data into the console and assign that data entered into a variable. You follow? So it's really simple to do this in Kotlin. So we use the readLine method for the user to enter data into the console. And by using this method, we can get the data that the user enters into the console. Okay, so of course, we can do the action we want to by transferring this data to a variable. Now, I would also like to partially touch on, if you will, the nullable issue here. Okay, so normally you would ask the user to enter some data, but let's assume that the user presses the enter key without entering any data. Well, in that case, you wouldn't have any data, and the program would throw up an error. But in Kotlin, in order to avoid this problem, all we need to do is use the readLine method in two different ways. So first, when we transfer the data we receive from the user to the variable, we need to put a question mark next to the data type of the variable. So this means that the variable we defined may or may not contain data, because we ask the user to enter data and the user may not actually enter any data. We're not actually going to know, but we don't want to throw up an error. So in this case, even if the user doesn't enter any data, we can prevent the program from failing. Now, a second spelling is to put 2 exclamation marks at the end of the readLine method. So this means that we're completely sure that the user is entering data. That is, even if the user does not enter any data, the program will assume that the user has entered some data, and an error can be avoided that way too. We're going to learn about that situation more in detail in our coming lessons. But here I just wanted to, like I said, briefly touch on the use of the readLine method so that you can start to let it sink in a little. Now, I do want to mention one more thing. The data that we receive from the user is always of the type string by default. And you know what? Actually, I'll just explain this with a short example. So let's say that you will develop a calculator application. So in this case, the user must enter values of the type integer or double, right? However, even if the user enters data of the type integer or double, we cannot operate using this data directly. Why? Because this data is taken from the user in a string type. So in that case, we'll need type conversions. As a result, if the user enters data other than string data type, well, first of all, we must convert this data to integer or double according to our application. Then we can use this data as we want to. So why don't we do this? Let's go to Android Studio now and do some practice. So first, I will create a new Kotlin file. I'll set the name of this file to be readLine. Now let's create our main method. Now, one of these things is, why don't we ask the user to enter their name and age, and then after the user enters this information, let's print the information entered by the user to the console. All right. So first, let's ask the user for their name using the print method. And I'll write, what is your name in parentheses. You can also use the print in method here. If you use the print method, the cursor will not move to the next line when the user writes their name on the console. They will have typed it against the expression here. You follow? So if you use the print in method, the cursor will move to the next line and will have written the username below the expression here. I mean, that choice is really up to you, but you got to know the difference. Anyway, now let's transfer the user's name to a variable named name and the type string using the readLine method. I'll write var name :string equals read line. So we've now assigned the name of the user to the variable named name. Now let's ask the user's age. So I can use the print method again. I'll write, how old are you, in parentheses. Now let's transfer the user's name to a variable named age and type integer. And we can use the readLine method once again. Okay, so I write var age :int equals readLine. Now, you know what? Let's create it with a second method too. So let me just delete the question mark here. I'll put 2 exclamation marks at the end of the readLine method. Now, pay attention to this. See how the code editor warns us? It's because the variable named age is of the type integer, but the data type that we get from the user is of the string type. So in other words, we are trying to pass a string data type to an integer variable. And of course, our trusty code editor warns us. So let's convert the string data type that we received from the user to integer type. Of course, you remember we use the toInt method for this. So here I'll write .toInt. And sure enough, as you see, the warnings vanished. So we took the user's name and age, passed it to variables. Now let's print the user's name and age to the console. So I write sout, press enter. And in parentheses, I'll write your name is and put the $, write the name variable. Remember, this way of writing allows us to write code inside a string expression. Good, so let's print the age of the user to the console. I'll write, and your age is, and here too, let's combine the two expressions using the plus sign instead of the $. So I write plus age. See, so I've shown you both in my clever way, both spelling styles. You can either print something to the console using a $, or you can print using a plus sign. The choice really is entirely yours, my friends. But I just want to show you how clever I am. So there we are. You know, what occurs to me is some people use the expression killing 2 birds with 1 stone. Well, I don't know. That just strikes me as not being very appropriate. So, my friends, let's now run our code. As you can see, there is an expression in the console asking for our name. So let's write in our name here. So I'll write David. And after typing in the name, press the Enter key on the keyboard. Next action should take place. So this time there is an expression on the console asking for our age. So let's enter our age here. Write 25. I press Enter. And once again, as you can see on the console, name and age are printed. Well, there you have it, my friends. Getting data from the user using the readLine method. We are definitely going to be using this method very often in our coming lessons, so why don't we take a short break here, and in our next lesson, we're going to learn control flow expressions. See, we're building and building and building. All right, see you in the next video. Well, hello, everyone. So in this next section, we're going to learn the fundamentals of Kotlin. We're going to learn decision-making statements, such as the if statement, the when statement. Then we're going to learn looping statements, such as for each, while, and do while loops. Very cool, because decision-making structures have one or more conditions to be evaluated or tested by the program. So if you look at the diagram, I'm going to show you if some condition occurs, check condition. If the condition is true, execute conditional code. If conditional is false, pass conditional code and continue. Now, there are 2 types of decision-making statements in Kotlin. They are if statements and when statements. So the if statement, this is used to test the condition. So it'll check the Boolean condition, true or false. And there are various types of if statements in Kotlin. We could easily classify these statements as if statement, if else statement, if else if ladder statement, and a nested if statement. So why don't we take a closer look at the if statement and if else statement syntax. All right, so first, the Kotlin if statement will test the condition. If the condition is true, it executes the if block. Secondly, the Kotlin if-else statement also tests the condition. If the condition is true, it executes the if block. Otherwise, the else block gets executed. So why don't we do some examples with this if-else statements in Android Studio. So what do we do? First, create a new Kotlin file, right-click on the package name, select New Kotlin File. After selecting the File option, I will name it if-else statement. Hit Enter. Create the main method. Write main, select the main A option here, hit Enter, and that way we get our main method created. So let's do an example like this. Let's ask the user to enter a number into the console. Then we'll let the user know whether this number entered by the user is an odd number or an even number. So first we'll define what the user needs to do. So I'll just write, please enter a number inside the print method. So now we'll pass that number that the user enters, right, to the console into a variable. So here I'm typing var number :int. I'm writing the equals readLine method. Now I'll put 2 exclamation marks at the end of the readLine method. But as I mentioned in the previous lesson, you remember the data that we receive from the user is always of the string type. So that means we have to convert it to the type integer. So here I'll write .toInt. Okay, so we took the number that the user entered in the console, converted it to an integer, and passed it to a variable named number. All right, so now let's check to see whether the number is even or odd. So we can tell if a number is even or odd by dividing it by 2, right? So if the remainder is 0, when we divide the number by 2, it is an even number. If the remainder is 1, it is an odd number. Okay, so we'll check this situation using the if statement. So here I'll write if, and choose the if option suggested by the editor. Cool. So after writing number in parentheses, I'll use the %sign and write 2. Now, do you remember that we were able to find the remaining number thanks to the %sign? So if the remainder is 0, then the number is even. So now I'll open up a curly bracket and press Enter. And this is the way that we define the scope of the if structure. Now, between these curly brackets, we must define the operations that should be performed when the number is even. So in this example, we will print to the console that the number is an even number. So that's what I'll write. That's out and press Enter. And I'll write the number after the $sign in parentheses. And I'm writing number is an even. So now let's run and test our code. Okay, so in the console screen, let's enter 8. 8 is an even number, so the condition is true, and the codes inside the body of if get executed. Okay, cool. So let's run the code again. And now on the console screen, let's enter 7. 7 is an odd number, so the condition is false, and the codes inside the body of the if are not executed. See how that works? That's very cool. And of course, it gets way more complex. But first, I want to show you how to add an else statement to this code. So if the condition is evaluated to be false, the else statement gets executed. So we add print method that includes number is odd text in the else block. Okay? So now let's run the code. And on the console screen, we'll enter 12. So we get 12 is even, and that's the message from the if statement. So that works. So now let's run the code and enter 13, and we get the 13 is odd message from the else statement. So there you go, my friends. That is how we use the if-else statement. So we're going to build on this from here, because in the next video, we're going to learn all about the if-else if statement, as well as my favorite and might become yours, the nested if statement. All right? So I'll see you in the next video. Well, hello, my friends. So right now, we're going to take a closer look at this if-else if. We call it a ladder statement and a nested if statement. We're going to take a look at the syntax. So first, the Kotlin if-else if ladder statement executes one condition from multiple statements. And secondly, the nested if statement represents the if block within another if block. So here, the inner if block condition executes only when the outer if block condition is true. All right, so let's do some examples with an if ladder and nested if statements. First up, what do? Create a new Kotlin file. Right-click on the package name, select the new Kotlin file option. So I'll determine the file name, and here I'll just call it if ladder nested if. Enter, and create a main method. Write main, select main A option, hit enter, and there is the creation of the main method. All right, so we're going to show a message to enter age by using the print method. And we will declare a variable, your age, with int type, and assign the readLine method to this variable. Also, I'm going to convert to the integer using the toInt method. Okay, so let's start to write the if statement. If your age is less than 13, then we will print you are a child to the output. Else, if your age is less than 19, we will print you are a teenager to output. If your age is greater than 19, else statement is executed, and we will print you are an adult to output. If all test conditions are false, codes inside the body of else is executed. Okay, so let's run the code. So back over on the console screen, let's enter 8. 8 is less than 13. So first if statement is executed. Output is you were a child. Cool, so let's run the code again. And let's enter 15. The program checks the first if statement. 15 is greater than 13, so the first if statement is not executed. So the second if statement is checked. 15 is less than 19. And yes, this condition is true, so this statement is executed. So then the output is, you are a teenager. All right, so let's run the code again. Let's enter 45. And the program checks the first if statement. 45 is greater than 13, so the condition is false. The program then checks the second if statement. 45 is greater than 19, so the condition is false. The else statement gets executed, so the output is you are an adult. Now, I want to add a nested if statement in the else statement. You'll see. So, if your age is less than 65, then we will print you are an adult to output. We add the else statement means that if your age is greater than 65, we will print you are a senior to output. Okay, so let's run the code. And in the console screen, let's write 56. Else statement gets executed because 56 is greater than 13 and 19. In the else statement, 56 is less than 65. So the if statement is executed, and the output is you are an adult. But now let's run the code again, and we'll enter 68. In the else statement, 68 is greater than 65, so the else statement gets executed, and the output is you are a senior. Yeah, you see how that works. So let's write a Kotlin program to find the largest of three numbers and implement a nested if statement. You with me? So first of all, let's convert the lines of code that we wrote here to the comment lines. And we'll show a message to enter three numbers by using the print method. So let's declare four variables whose names are number 1, number 2, number 3, and largest number with the integer type. And assign readline.toInt methods to these variables. Now look, I'm not going to set the initial value of the largest number variable. Instead, I will pass the largest of the three numbers entered by the user into this largest number variable. So if you're within the bounds of a function, you may not be able to initialize variables. Yeah, we're going to cover that topic a little later in the next lessons, but let's start to write the if statement. So if number 1 is greater than or equal to number 2, this is outer if, yeah. So we add a nested if statement. If number 1 is greater than or equal to number 3, then assign number 1 to largest number. Now you're getting it. Else assign number 3 to largest number. All right? So why don't we continue with the outer else statement? We'll add a nested if statement again. If number 2 is greater than or equal to number 3, then assign number 2 to largest number. Else assign number 3 to largest number. Yeah, you're cooking with gas now, so let's print the largest number to the output by using the print method. Okay, you ready to run the code? So in the console screen, we'll enter 6, 5, and 12. So the program will check the outer if first. 6 is greater than 5. The condition is true, so outer if gets executed. In the outer if, the program checks the inner if. 6 is less than 12. The condition is false, so inner if is not executed, and the else statement gets executed. And 12 is printed as the largest number. Very cool. So let's run the code again, but this time we're going to enter different numbers. How about -2, 1, and 0? And as you can see, the largest number is 1. Ha! So what do you think of that? I think it's pretty cool. So thanks for sticking with it. And that's enough of the example stuff, right? At least to understand the if statement. To make it clear, though, you got to do some more exercises. So Stay tuned for the next video. See you then. Well, hello everyone. So in this video, we're going to learn how to use the when statement and understand how to control the flow of our program's execution. So the when statement executes one statement from multiple conditions. So you might think it's like the if-else-if ladder statement that you learned in the previous video. The when statement works with data types such as byte, short, int, long, and string. As you can see in the diagram, when the statement starts with when, which is a keyword, and a conditional expression between brackets. If condition 1 is true, code block 1 gets executed. If condition 1 is false and case condition 2 is true, code block 2 is executed. If condition 1 is false and condition 2 is false, if condition n is true, code block n is executed. Now, if all case conditions are false, the codes in the else block are executed. Now, there are some important points when you're using this when statement, so let's consider them. There can be one or n number of case values for a when expression. The case value must be of when expression type only, and the case value must be literal or constant. We cannot use variables here. So let's make some examples, and we'll use some when statements. So first, I'm just going to create a new Kotlin file, so I'll right-click on the package name, select the new Kotlin file option. After selecting the file option here, I'll determine the file name, and I'll just call it when statement. Hit enter. So now I've got to create the main method. I'll write main and select the main A option here and enter. Okay, so now we've got the main method created. So let's do up our example like this. We'll ask the user to enter a number between 1 and 7 into the console, right? So we'll print the day of the week to the console according to the number entered by the user. So, for example, if the user enters the number 1, we'll print Monday to the console. If they enter the number 7, we'll print Sunday on the console and everything in between. All right? So let's get right into it. First up, we'll prepare a message that informs the user. So let's write, please enter a day number of the week here. Now I'll create a variable of the type integer called day number. Then I'll pass the value entered in the console to this variable. Now let's create a variable of the type string. But we cannot initialize this variable, right? So we're going to pass the days of the week to this variable. Now let's create the when statement. So I type when, and then select the when option suggested by the editor. So I'll write the day number variable inside parentheses because we have to pass a value entered in the console to this variable. Okay, so now let's create the conditions. So I'm writing 1. Then I'll add a dash and a greater than sign. This expression is called the lambda. All right. So after the lambda, we must define the operation that needs to be done. So if the user enters a number 1 in the console, we should print Monday to the console, right? So for this, I'll pass the value Monday to the day variable. And that's how we've created our first condition. Yeah, so now we have to create the other 7 conditions. So for this, I just need to copy and paste this condition 7 times. Then if the user enters the number 2, let's make it Tuesday, If the user enters number 3, it'll be Wednesday. Enters 4, it'll be Thursday. 5, it'll be Friday. 6, Saturday. And finally, if they enter the number 7, it will be Sunday. All right, so now if the user enters a different number, we've got to create that else condition for that scenario. So in this case, we can pass the following expression to the day variable, invalid day choice. So now why don't we go ahead and print the day variable to the console outside of the when statement. So after typing S out, I'll press enter and I'll write day is $day in parentheses. Okay, so now let's run the code. Enter 3 for the day number of the week. Case condition 3 is executed and day is Wednesday is the message that gets displayed. Cool. So let's run the code again. Enter 5. Case condition 5 is executed and day is Friday is the message that gets displayed. All right, so let's see what happens when we run the code and enter 8. See, so the default part of the when statement gets executed and the invalid day choice message gets displayed. Perfect. So yeah, my friends, now you get a pretty good understanding of how that when statement gets used. So why don't we just take a short break here, and then in the next lesson, we're going to learn some loops, all right? So I'll see you on the other side. Well, hello, friends. If you're here watching this video, that means you made it to the other side. That's cool, huh? So in this video, we're going to learn the for loop. So in computer programming, a loop is basically a sequence of instructions that is continually repeated until a certain condition gets reached. So when we need to execute a block of code several times, we'll use looping statements, right? So yeah, let's just go in order here. We're going to first learn how to use the for loop in Kotlin programming language. The for loop, of course, is a control flow statement that iterates a part of the programs multiple times, right? So the general form of the for statement can be expressed as you see here in the slide. So here we see the use of the range2 method and the in operator, which we learned in our previous lessons, right? Yes, we did. So this is pretty much how the for loop gets used in general. Here the I actually represents a variable, and when the program runs, each value in the defined range is passed to the variable I in turn. Then as a result of each transfer operation, the code defined in the loop runs. All right, so now we got that out of the way. You see this for loop execution flow on the slide, right? Here, the first step. In for loop, the initialization part only executes once. The second step, the range in the for loop, is evaluated on each iteration with the in operator. And that way, if the range is not over, then the loop body gets executed. If the range is over, well, statements in the loop body do not get executed, and control gets transferred to the next statement in the program after the for loop. All right? So let's open Android Studio. We're going to do some fun practice here. I'll show you. All right, so first off, I want to create a new Kotlin file, so I'll right-click on the project package folder, and I'll choose new Kotlin file, and then I'll choose the file option and set the name of the file to be for loops. And let's create the main method. All right, my friends, so we're going to try to understand the for loop with a few simple examples, all right? So first, let's print the numbers from 1 to 10 to the console. So I'm writing the for here. I'll select the for statement suggested by the editor and press enter. Now let's write a variable name inside parentheses. So you can write anything that you want to here. I am just typing number. And then I'll write the in operator. And then finally, since we'll print numbers from 1 to 10, I'll write 1.10. Thus, when the program runs, well, all numbers from 1 to 10 will be transferred to the variable in order. So, of course, we must define the operations that we need to be performed when each transfer operation takes place. So for that, I just create curly brackets here and press enter. So we also set the scope of the for loop, right? All right, very cool. So now let's print each element from 1 to 10 to the console. So for this, what do I type? That's out, press enter. And I'll write number in parentheses because numbers from 1 to 10 will be transferred to the number respectively. We will print this number variable to the console every time. All right, so it looks set. Let's run the code. In the console, we should see the numbers 1 to 10. And there you go. So obviously, it's an easy example, but we have now printed the numbers from 1 to 10 on the console. So why don't we do another example? Let's see if we can heat it up a bit. We'll print the numbers from 0 to 5 and sum of these numbers to the console. That would be the sum of these numbers, not just sum of the... Anyway, I'm converting the code here to the comment line. Okay, so now I will create a variable called sum and type integer. The initial value of this variable will be 0. So now let's create the for loop. So I'll write for x in 0.5. I'll define the scope of the for loop with curly braces. Now I want to print the numbers from 0 to 5 to the console. So I write x in parentheses. Now let's transfer the sum of the numbers from 0 to 5 to the sum. So for this, I'll write sum plus equals x. All right, so if you remember this expression, we'll add sum and x and pass a result back to the sum variable. See how that works? But let me break it down a little bit here. Since the initial values of sum and x are 0, the initial value of the sum variable will be 0. Then when the loop runs again, the new value of x will be 1. So first the number 1 will be printed to the console, then sum and x, that is 0 and 1, will be added and transferred to the sum variable. So the new value of the sum is now 1. The loop will run once again, and the value of x will be 2. And then 2 will be printed to the console. Then sum and x, that is 1 and 2, will be added and passed to the sum variable. And as a result, the new value of the sum variable will be 3. And then the loop will continue to run like this, right? You see where this is going? Pretty cool though, huh? Now, outside of the for loop, let's print the sum variable to the console. So I'll write sum of numbers in parentheses. And now I'll write the variable sum after the $sign. Now let's run our code. All right, so as you can see, we first printed the numbers from 0 to 5 on the console, and then the sum of the numbers from 0 to 5. So I do want to do another example to reinforce this concept of the for loop. This time, though, we're going to print the even numbers from 0 to 10 and the sum of these numbers to the console. Okay, so for this, I'll just copy these codes that we wrote here, and I'll paste them here. Now I just want to convert these code to the comment line. Okay, so first I'll set the last value of the range to 10. Now, if you remember, we were dividing by 2, right, to find out if a number was even and If the remainder is 0, then we know it's an even number. So for this, we will use the if statement here, right? If x% 2 equals 0, the x is an even number. So I'll cut the print method and the codes that we wrote for the sum operation here and paste it into the if block. Right? Okay, so that's it. Finally, I'll write even and here. You follow? So now let's run and test our code. And there, as you can see, the even numbers from 0 to 10 and the sum of these numbers are printed on the console. All right, so that's just a few quick examples of how the for loop is used and how I'm sure it kind of triggers what you can do with it. So what we're going to do is learn how to use this for loop with arrays. All right, so I'm sure you remember when we were learning about arrays, when we were printing the elements of an array to the console, we used a separate print method for each element. So if our array is an array of 1,000 elements, well, do the math, right? You're not going to sit there and write out 1,000 different print methods. Of course not. There's got to be a better way. This is a computer, for goodness sake. So in that case, we can use the for loop. So why don't we just do a quick example right away. So I will convert the codes here to the comment line. Now let's create a new array. So first we will need to determine the name of the array. So here I'll just write my number array. All right. Now after the equal sign, I'll write array list of, and let the type of the array be integer. Now let's determine the elements of this array. Let the elements of the array be from 1 to 10. And now the array is ready. So now we can print the elements of this array to the console using the for loop. So after typing y in this parenthesis, this time we will write the name of the array instead of the range. Thus, each element in the array will be transferred to the variable y respectively, right? You follow that? So now let's print the y variable, that is, the elements of the array, to the console. So I type s out and press enter and write y in parentheses. All right, so let's run our code. There you go. So we've easily printed out all the elements of the array to the console. That's very useful. However, let's see how we can access the index numbers of the elements in the array. So you could actually use a couple of different methods for this. First, I'm just going to copy and paste the code here and convert these codes to the comment line. Okay, so to find out the index numbers in the array, we can create a range here from 0 to 1 less than the array size. Why would we do that? You remember, index numbers always start from 0. So that means that the last index number will be 1 less than the array size. All right. So the size of the array is 10, and index numbers from 0 to 9. Therefore, numbers from 0 to 9 will be transferred into the y variable, respectively. Now let's print the elements of the array to the console using this index number. So I'll write my number array, and I'll open square brackets, write the y after the $sign. Now this expression will allow us to see the index number of the array in the console. So now let's print the elements of the array. So after typing equals using $sign and curly brackets, I write my number array. And inside the square brackets, I'll write y. All right, so let's run our code. And there you go. That prints the index numbers of the array and which element is in which index right there in the console. So now let's try to access the index numbers with a different method, all right? So, well, first we'll write myNumberArray.indices here. And you know what? We're even going to turn these codes into comment line again. So let's copy and paste these codes again. And since I will share these codes with you, it definitely would be useful to see them all here. That's why I'm doing this, right? So all you have to do is write the name of our array here, that is myNumberArray, and use the .indices method. That way we can directly access the index numbers of the elements in the array. So let's run the code one more time. And there you can see we have now printed the array's elements and index numbers to the console. Now, is there a difference between these two ways to do it? No. You can just choose whichever one is easier for you. So finally, I want to talk to you about this for each, right? Because it's another loop and it's called for each. And it's defined in Kotlin programming language. In fact, the work of this loop is almost the same as the for loop, but to me, I kind of think of it as just far more practical. So you can print the elements of the array here to the console much more easily just by using the for each loop. So without any further ado, let's learn how to use the for each loop, and then I won't be holding it out on you any longer, right? So first I'll just copy and paste the array here. And now let's turn these codes into the comment line. Okay, so now let's print the elements of the array named myNumberArray to the console using the for each loop. So first I'll write the name of the array, that is myNumberArray. Then I write .for each. I choose the for each as suggested by the code editor. And finally, I'll write the printin method, and I'll write it in parentheses. So here the it is a variable defined by this Kotlin programming language. And it represents each element in our array. So now let's run and test it. All right, so see, we have now printed all the elements of the array to the console. It's pretty cool. So anyway, that's how the for each loop gets used. But we mostly use the for loop in our projects going forward here. Although the for each loop is very simple to use, the for loop is often preferred by programmers because it just gives you a little bit more flexibility, when you're working, especially when you're working in groups or teams. All right, my friends. So yeah, that's about it. We've learned about the different uses of the for loop. So why don't we just take a short break here, and in the next video, we're going to learn about the while loop. And it's got nothing to do with coyotes. Ha! All right. See you next time. Well, hello, everyone. So this is the video that we're going to learn about the while loop. Not whiley loop, while loop. All right? Just like the word. So in the while loop, the controlling variable is previously defined. All right, so the condition is evaluated first, and if it returns true, then the statements in the loop body are executed. So generally, the loop body contains an update value for the variable being processed for the next iteration. You follow? If the condition returns false, the control comes out of the loop and jumps to the next statement after the while loop. All right, so let me show you a few examples using while loop. So first, let me just create a new Kotlin file. And we'll call this file while loop. See, while. Now let's create the main method. All right, so let's do our first example like this. We'll print the numbers from 5 down to 1 on the console. So for this operation, I'll just declare a variable I with the initial value 5. And now we'll create the while loop. So I'm typing while here, and look what our code editor suggests. So I'll just choose the while option, and I'll write I greater than 0 inside the parentheses, because I want this loop to continue as long as the value of I is greater than 0, right? All right, so we've created the condition. Now let's define the scope of the while loop. We use curly braces for this. And in this field, I will define the action that I want to be done. So we should print the value of I to the console every time the loop runs. So for this, I write s out, press enter, and I write I inside the print method. Also, we'll need to update the variable I, so we decrease the value of I by 1. All right, so let's run the code. And there you can see the numbers 5, 4, 3, 2, and 1 are printed on the console. So after 5 iterations, I will be 0, then our condition I greater than 0 is evaluated to be false, and the while loop terminates. Okay, so why don't we write a program to calculate the factorial of the first 5 numbers? Well, first of all, maybe we ought to clear up this factorial, all right? You might have forgotten, right? Some of our friends out there might just be, well, I don't know. It's reminiscent of something. Anyway, the factorial of a number is obtained by multiplying the numbers from itself to 1. For example, when calculating the factorial of 3, well, you multiply 3, 2, and 1, and we can say that the factorial of 3 is 6, right? Or I'll give you another example when calculating the factorial of 5. Just multiply the numbers 5, 4, 3, 2, and 1, and we can say the factorial of 5 is 120. All right, so there you go. That's factorial. Now let's start coding. So we'll declare 2 variables. First, k with the initial value 1. The second, fact with initial value 1. Let's start the while loop with the condition k is less than 6. So in the loop, we'll assign fact multiply k to the variable fact with multiply and assignment operator. So if you remember, this spelling means fact equals fact times k. Yes, of course you do. So why don't we print the value of k and fact variable by using this print method? So in parentheses, I'll write k after the $sign and put the exclamation point. Because remember, in mathematics, the factorial is represented by an exclamation point. I remember when I was a kid, I used to think it was an angry number. But anyway, I'll just write equal $sign fact. Cool? Cool. Now we've also got to increase the value of k by 1. So the loop will continue, right, until the value of k is 6. And each time the loop runs, the factorial of k will be calculated and printed to the console. And then when the value of k becomes 6, that loop will end. All right? So let's run the code. Factorial of 1 is 1. Factorial of 2 is 2. Factorial of 3 is 6. Factorial of 4 is 24. Factorial of 5 is 120. So you see that? That's how that works. That's cool, huh? It gets kind of exciting. But that's why I want to bring up to you the idea of infinite loops. Yes, there are such things as infinite loops. So just imagine. Not a Mobius in this case, but in infinite loops, the loop continues just like it is until the desired condition is met. The loop only terminates when the desired condition is met. You see what that means, right? So if you notice in the examples here that we've done so far, we've set a condition and continued the loop until this condition is met. It's a very specific condition. We use increment or decrement operations for the end of the loop, right? But here we determine how long the loop would take. That's why it's here. So what do you do then if you don't know how long the cycle is going to last? But obviously you don't want it to just continue forever and ever. Well, I'll just explain it with an example. How's that? So let's say, for example, you will develop a number guess application, right? So in other words, the computer is going to generate a random number in the range that you specify, and then you'll ask the user to guess this number, right? That's always fun. So if the user cannot guess the number randomly generated by the computer, well, they're constantly asked to enter a new guess. So as long as the user doesn't guess a number correctly, well, an infinite loop will continue. And then if the user guesses the randomly generated number, the loop will terminate. So then as a result, we're going to want to run some code to run continuously. Then we're going to use an infinite loop. So infinite is only implied, right? So why don't we do that simple number guess application? Because I think it's pretty fun anyway, and it's simple to set up. And this way you will definitely be able to understand the concept of the infinite loop so much better. So first off, we'll need to generate a random number. For that, we can use the class named random in Kotlin. What do you think of that? So I'll write random in here with the first letter capitalized. So as you can see, the editor offers a few different options called random. So from here, I'll choose random, which is a class from the Kotlin.random package, represented by the letter C. We'll press enter. And then when you type .next, as you can see, a lot of options appear. So we can generate random numbers of the type integer, double float. So here I'll just choose the next int method. And finally, I've got to specify the range of the numbers to be generated. So for this, why don't we just generate a random number between 0 and 100, all right? So I'll just write 0, 100 here. So generating a random number in Kotlin is pretty doggone easy, don't you think, my friends? So now we've got to transfer this randomly generated number to a variable. So I'll write val number equals, at the beginning of this code, thus a random number between 0 and 100 will be generated and then passed to the variable number. All right, so now we have randomly generated number here. What are we going to do with it? Well, we're going to take the user's guess. So first, let's just deliver a message that informs a user. So I'll write, please enter a number in parentheses. Now, let's create our infinite while loop. So after typing while, we've got to write an expression in parentheses that will always be true. All right? For example, we can write 2 is greater than 1, or we can write true, right? It's enough that the expression that you write here is correct. Doesn't actually even matter. You can write anything you want as long as it's true. So for now, I'm just writing 2 is greater than 1. We'll keep it simple. Now, let's take the user's guess, pass it to a variable. So here I'll write val user guess equals read line double exclamation mark dot to int. You see that? So we can now evaluate the user's guess using the if-else statement. If the user guess equals the number, let's message the user, hey man, congratulations, you know the number in my mind. Of course, if the user's guess is correct, the condition will be satisfied, and then the loop's going to have to end, right? So how would we end the loop in this case? Well, for this example, it's enough to write the break keyword here. All right, so as soon as you type the break keyword, your loop will end. Now let's create the other conditions. All right, so here I want to use the else if statement. If the user's guess is less than the randomly generated number, we can tell the user to increase their guess. And then finally, in the else block, well, we can use this to tell the user to decrease their guess, right? Because the last condition is that the user's guess is greater than the randomly generated number. All right, my friends, so we've created the infinite loop. This loop will indeed continue until the user guesses correctly. So what do you say we run it and test our code? All right, so there you go. There's an expression that tells us to enter a number in the console. And we've got a value between 0 and 100 that's generated and passed to the variable number. And when we enter a guess, the guess will be compared with the variable number. I'm just going to type 50 as a first guess, press enter. Okay, so yeah, you don't necessarily know the randomly generated number, so we'll need to decrease our guess. And for a second guess, let's type 40, press enter. Well, what do you know? I got it wrong again. This time I'll need to increase my guess. Okay, so see, we're getting somewhere. So now I'll enter 41. Need to increase it again, enter 42. What do you know? Ding, 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 ding. I guess we ought to animate some balloons or something, huh? But not in this course. So as you can see, the loop will continue until a correct guess is made. Far out. So when we guess correctly, that stops the loop. Unfortunately, you were kind of hoping that it was going to go on for at least a day or two, right? Well, it's only 0 to 100. Anyway, that's what you call an infinite loop. So I hope you had fun with the concepts of while and infinite loop, and you have a little better understanding anyway. So we're going to take a short break here, and next up in our next video, we're going to learn the do-while loop. All right? I'll see you in the next video. Hello, everyone. All right, so in this video, we're going to learn about the do-while loop. Now, the do-while loop could be considered similar to the while loop, with the only difference is that it checks for the condition after executing the statements in the loop body. So in other words, there's no checking of any condition at the outset. Okay? So after the execution of the statements in the loop body and the update of the variable value, the condition is then checked to be true or false. So then if it's evaluated to be true, well, the next iteration of the loop starts. If the condition returns false, the loop terminates and jumps to the next statement after the do-while loop. So the statements in the loop body are executed at least once before condition controlling. That is the most important point. So, why don't I show you a few examples with this do-while loop. First up, I'll create a new Kotlin file. I'll name this file as do-while loop. And now let's create the main method. All right, so we'll write a program that prints int numbers from 1 to 15. Let's declare a variable number with initial value to be 1. Now let's start the do-while loop with the do keyword. Now in loop, we'll use the print method to display numbers. So I'll put a $sign before the number. We need to update the variable number. So we increase the value of number by 1. And now we add a loop condition with the while keyword. Our condition is number is less than or equals 15. All right, so let's run the code, see what we get. And look, what about that? Here are the numbers from 1 to 15 right there on the screen. So in the do-while loop, the print process and increment part of the body is executed at least once before the condition. All right, my friends, that's how the do-while loop works. So yeah, we've learned about the loops that we use in Kotlin. So just want to take a quick break here and we'll talk about methods in the next video. All right, so see you in the next one. Well, hello everyone. So in this section, we're going to introduce functions in Kotlin. Yeah, so first we'll learn what is a function and how do you create a function in Kotlin. We will then learn declaration and calling of functions. Then we will learn function types. And then we will learn function return types. All right, so a function is a set of statements to perform an operation. Functions are also known as procedures, as well as functions. The main advantage of function is code reusability. So you can write a function once and then use it multiple times. You do not have to rewrite the entire code each time. So you can think of it like write once, reuse many. I don't know. I thought it was going to be cool, but, you know, one to many, once many. Once you write it, you can use it a lot. All right, so you see the general form of a function declaration right here. A return type is a data type of the value that is returned by the function. It can be a primitive type, such as int, a class type, such as string or unit. Each function has its own name. So a function name begins with a lowercase letter and compound words. So in multi-word names, the first letter of each of the second and following words need to be capitalized. Now, we're going to discuss our naming rules for functions in the coming lectures, but for now, just park that in the back of your head. A parameter is a value passed to the function. Functions can take one or more parameters. So if the function has more than one parameter, then these parameters are separated by commas. If functions work with data, we must pass the data to the functions. And this is done by specifying them inside of parentheses. If the function does not take any argument, simply leave the parentheses empty. If any function is not declared unit, then it must contain a return statement with a corresponding return value. The data type of the return value must match the function's declared return type. So you can't return an integer value from a function declared to return a Boolean, right? That makes sense. But don't worry, we'll cover function return types in much detail coming up. So the function body, which is enclosed between braces. The function body includes the declaration of variables and some other codes of functions. Now, finally, in our example, we define the function that its name is addNumber with the integer data type, and we have x and y parameters. Our function finds the sum of x and y and saves the result in a new variable sum, and then returns the value of that variable sum. Also, we can directly return the x plus y statement instead of assigning a new variable. So, my friends, this is the general structure of functions in Kotlin programming language. Now, of course, we can use this function that we created wherever we want. If we do not use it, the operations that we define inside the function will not occur. So in other words, we have a function, but the function cannot perform its function. So how can we call a function that we created? That's what we're going to find out right now. So a Kotlin function is called according to its functionality. It is called in any of these two situations. The first one when it completes all the statements, and then the second one when it reaches a return statement. So in this example, we'll define a variable result with the int data type. Its initial value is 0. We call the add number function with arguments 10 and 20. Argument values are passed to the parameter. Arithmetic sum is the operation that gets performed in the add number function, and the return value of add number function is assigned to variable result. And now we show the result value 30 on the screen. Also, we can directly use the add number function with the print-in function instead of assigning a new variable. But as you see, the result is the same. All right, my friends, that's in general how you use functions in Kotlin. Now, don't worry, though. We're going to go over it a lot because we're going to reinforce this subject by doing many, many examples in a little bit. But first, I bet you want to learn the types of functions, right? So we're going to take a short break here, and I will see you in the next video. Well, hello, my friends. So here we are in this video learning about types of functions. Who knew that our lives would turn out like this? I'm just playing because this is where it really starts to break open for you. So we've got two different types of functions in Kotlin. First one is standard library functions. The second one is user-defined functions. Whoa, customization. Yes. Just a moment, though. Put that thought on hold. Kotlin has a library of predefined classes and functions. They're organized into packages. Now, in order to use these functions, we import the packages and use them directly in our program. We'll cover the subject of packages in the next few slides, but right now I want to give you an example. Do you remember the first Kotlin program that we wrote together? We used the print function to write hello world on the screen. Right. The print function is, of course, a standard library function. Now, in addition to using Kotlin predefined functions, we can also write our own functions. In order to write a function, first off, you decide what you want it to do. Then you write the definition of the function by providing the return type, the name of the function, and its parameters. For example, the add number function that we defined in the previous lecture is an example of user-defined functions. In fact, every function in Kotlin returns, well, either some value or nothing, no value, right? So if it returns a value, this value can be either primitive or non-primitive. The unit keyword allows us to create functions that do not return a value. Of course, if we do not specify the return type of the function that we created, Kotlin automatically accepts it as a unit, that is, a void function. So these functions perform a set of tasks without a return value. So when a function doesn't return a value, it is indicated by the keyword unit after the name of the function. So if you declare a function with primitive types, your return type of function must be the same. Primitive functions return char, byte, short, int, long, boolean, float, and double types. If you declare a function with non-primitive types, your return type of function must be the same. Non-primitive functions return reference data types, such as object of the class, string, stuff like that. Now, why don't we go ahead and open up Android Studio now, and we'll get a little practice in. So first, we'll create a new Kotlin file. So I'll specify the name of this file as functions. Now, let's create the main method. And I'm sure you remember we have defined all the operations that we've done so far in the main method, yeah. However, defining all the operations that we will do in the main method can sometimes create a complex image. And for this very reason, we can define the operation that we want to do in a different function that we will create. And in the main method, we can define the operation we want to do by simply calling the function that we created. So now I'll show you an example. It goes like this. Let's ask the user to enter two numbers into the console. So let's print the numbers entered by the user, the sum of these numbers, and the smaller number of these two to the console. But we're going to do all of these operations using the functions we will create ourselves. Don't think it's possible? Well, stick with me, I'll show you. So here I'm going to create a new function outside of the main function. So I'm writing fun here, and fun it is. So this fun statement declares that it's a function, right? Now, let's define the name of the function. So I'll set the name of the function. I'm going to make it show, because this function will show the numbers that the user enters into the console. And since we will receive two numbers from the user, well, that means I've got to specify these numbers as parameters, right? So numbers are parameters. So for that, I'll write num1 of the type integer to represent the first number in parentheses. After putting a comma, I'll write num2 of the type integer to represent the second number. See how that works? So this function will show the numbers that the user has entered into the console. So it's not going to do any different operations. Therefore, this function will be a unit. That's right. That is a void function. Now, for the unit function, you can write unit after putting a colon here, or you can write nothing. So if you don't write anything, Kotlin treats this function as a unit function anyway. Now, we will use unit functions that do not return a value just like this, all right? But right now I want to define the scope of this function with curly braces. So inside of these two curly brackets, we must define the operation that this function should do. So in other words, we need to specify what work this function is going to do once it's called. So since this function will display the numbers entered by the user in a console, I will write the code here that will display only the num1 and num2 parameters in the console. So I'll type as out and press enter. I'll write you entered in parentheses. Now you remember num1 and num2 were of the type integer, therefore I have to write them after the $sign. So I'm typing $num1, $num2. Cool, so we've now created our very first function. So now let's create the second one. So this function that we will create will print the sum of the two numbers entered by the user to the console. Now I'm also going to set the name of this function to be add. Again, this function will take two parameters because the user will enter two numbers into the console, and we must specify two parameters to represent these numbers. In addition, these parameters will be of the type integer. Of course, you can operate on any data type that you want to, but for now, we're going to use the integer type. So, we also want this function to add two numbers and give us the result of that operation. So this function will return a value. And the return value will also be of the type integer. So that's why I'm typing int after putting a colon here. Now we can define the scope of the function with curly braces. Now notice that the curly braces here are underlined in red. Huh? Because this function is a function that returns a value. So we need to return an integer value using the return keyword in this function. And unless we do it this way, we will continue to receive this warning. So we will use the return keyword in a moment, but first let's create a variable to pass the sum of the two numbers. So here I'll write var sum equals 0. Now let's transfer num1 and num2, that is the sum of the two numbers that the user enters into the console, to this variable named sum. And here I'll write sum equals num1 plus num2. Then finally, we'll need to return the result of this operation, namely the variable sum. So that's why I'm writing return sum here. All right, so you see that wherever we call this function, it will give us the sum of the two numbers we give as parameters. So we've created our second function. That's a big deal, because now we're going to create a third function. So we're going to let this function give us the number that is less than the two numbers entered by the user. So it'll be a function that returns a value again. I'll also make the name of this function, I'll call it find minimum number. Now notice that the name of this function consists of 3 words. We also capitalize the first letters of the second and third words. So this spelling is called camel case, and it's used for functions and variables. You can also make names here by placing an underscore between the words, but pretty much you want to be using camel case because that's how it's used in the community. Now let's write our parameters in the parentheses, and here you can specify the name of the parameters however you want. So I'm just typing in num1 and num2 in this example, but you can also type in names like A or B or X and Y, whatever. But the important thing here is that there is a variable that represents the numbers that the user enters, whatever that would be, okay? So again, this function will return a value of the type integer. So now let's define the scope of the function with curly braces. And now we can define the work that this function should do. And this function will compare two numbers entered by the user and give us the smaller number. Therefore, we should use an if-else statement here. Wouldn't you agree? Now, of course, we'll define a variable of the type integer first because we're going to transfer the smaller number to this variable and then return this variable. So here I'll define a variable of the type integer named minimum. Not going to initialize this variable, but we will create the if-else statement. If num1 is greater than num2, num2 is smaller, and therefore we must pass num2 to the variable named minimum. Cool, you follow? Awesome. Now let's create the else block. Else, that is, if num1 is not greater than num2, this time num1 is smaller, and we need to pass num1 to the variable named minimum. All right, so finally we got to return the variable named minimum, right? So here I'll write return minimum, and there it is. Okay, my friends, so we've created our functions. Now we'll need to call these functions inside the main method, because when we run the program, the main method's going to run. The main method will also run our functions. So for that reason, we've got to call the functions that we created inside of the main method. Of course, before calling the functions, we've got to specify that the user must enter two numbers into the console. So to do that, let's write the print method here, right? Please enter the first number. And we'll write that in parentheses. So now let's take the number entered by the user and pass it to a variable. Here I'll write var number1 The type of this variable will also be integer. To the right of the equals sign, I write the readLine method and put a double exclamation mark, and then write the .toInt method. And you remember, right? That way the number that the user enters in the console will be converted to an integer and transferred to the variable number1. Now let's get the second number from the user. So for this, I can just copy and paste these 2 lines of code. I'm typing second here, and I'll also name this variable number2, and we've got the numbers now from the user. Cool. So now we've got to call the functions that we created. First, I will call the function named show. So you just write the name of the function here. And as you can see, the code editor offers us the function, the show function that we created, right? So we can also understand from here that this function is a unit function. So after calling the function here, if you notice it wants us to enter parameters of the type integer, that is argument, which represent the num1 and num2 parameters in parentheses. So I'm writing the variable number1 to represent the num1 parameter. For the second parameter, I'll write the variable number2. Now let's call the second function. So I'm typing in add here. And as you can see, our trusty code editor offers us the add function that we created. So we can also understand from this that the function will return a value of the type integer. All right, so after calling the function here, you notice that it wants us to enter the parameters of the type integer. So that is the arguments, which represent the num1 and num2 parameters in parentheses. So here I'm writing the variable number1, and that'll represent the num1 parameter. And for the second parameter, I can write the variable number2. Now, since this function will give us an integer type value, we can also transfer this value to a variable. So here I'll write var a equal. Now let's print this variable named a to the console. So here I type S out and press enter. I write sum of the numbers equals $a in parentheses, and that completes the second function. Hang in there, we're almost there. So finally, I'm going to call that third function, and again, I'll write number1 and number2 as parameters. Also, I have to pass that into a variable as well, so here I'll write var b equals. Now, let's print this variable named b to the console. So here I type S out, press enter. I write the minimum number is $b in parentheses. And there you go, my friends. We've called all the functions that we created. Okay, but before you celebrate, we got to run this program. So I'll right-click on the functions file, select Run. And just like that, look at that. So the program works, right? I enter the first number, 8, press Enter, and it asks us to enter the second number. So I'll enter a second number, let's do 12. So after pressing Enter, the show function works first, and the you entered 8 and 12 expression appears on the console. Then the add method works because right here you can see this is the sum of 8 and 12, 20. Right here it's printed to the console. And then finally the find the minimum number function works because it's compared 8 and 12 and printed the smaller number 8 to the console. All right, my friends, that's really cool. I mean, that's some great stuff that you've mastered here, right? If you don't quite get it, please go back and review it, because once you get it, boy, this is a great tool. That's the way you use functions, all right? It's going to make your coding way easier, and you'll also be able to build more complex structures using functions, just like that. So we're going to take a short break here, and I want to see you in the next video. Well, hello, friends. So in this lesson, we're going to learn a concept of object-oriented programming. Now, as we talked a little bit about before, Kotlin programming language is also an object-oriented programming language. Therefore, we're going to need to learn, well, the concept of object orientation. All right? So what is object-oriented programming? OOP, or object-oriented programming, is a method of designing and implementing software. The primary purpose of object-oriented programming is to increase the flexibility and maintainability of programs. It simplifies software development and maintenance by providing some concepts. Now, these concepts are object, class, inheritance, polymorphism, abstraction, and encapsulation. Now, we're going to get to these subjects each in its own time and in very great detail in the coming slides. But I want to start with the concept of object orientation. A class is a group of similar entities. An object can be defined as an instance of a class. Objects are often used to model real-world objects that you'll find in everyday life. So a Kotlin object is a self-contained component that consists of functions and properties. So an object contains an address and takes up some space in memory. A class doesn't consume any memory space at all. Okay? So the object has three characteristics. It's got state, behavior, and identity. So now let's get into these characteristics a bit more. So the state represents the data of an object. The behavior represents the action of an object, right? Such as the start, stop, etc. The identity. This is used internally by the Java virtual machine in order to identify each object uniquely. The value of ID, though, is not visible to the external user. So when you think of a car, well, it's called a Ferrari, right? Its color is red. Let's say the model is 2015. So these are its state. This car starts and stops. So starting and stopping are its behavior. All right, so let's do an example with object and class. So for instance, we'll define a car class. And the properties of an object, car would be model, color, and year. An object will also execute some actions, right? Using the car, well, this car is capable of performing the following actions: start, stop, accelerate. So now, as you can see on the slide, for different values of properties, the model, the color, the year, in the class car, we will get different car objects. Cool? So in our example, we have one class. Also, we have three objects. You can also create an unlimited number of objects from a class. So now let's quickly jump, and I want to show you how to define a class in Kotlin. Now, class is declared by using the word class. So this is a keyword. The class body is enclosed between curly braces. The data variables will be defined in the class, and these variables are called instance variables. The action code is written in the method. All code blocks are in the class body. Variables and functions are defined in the class, and then these are members of the class. So now when you're creating an object in Kotlin, an object is created from a class. Creating objects from any class is quite simple, my friends. The expression var here represents a variable. And then next we'll need to give a name to the object that we will create. So in this example, I'm going to make the name of this object my car. And you can, of course, name it whatever you want. But then on the right side of the equal sign, I've got to write the name of the class that we will create the object. And that's it. So here, the myCar object is the reference that holds the memory address of the car object. So yes, my friends, there you go. That's a brief explanation of the concept of object-oriented class and object concepts. All right? So we're going to take that forward because it's very useful information. But first, we'll take a short break. And then when we pick up next, we're going to talk about access modifiers in Kotlin. All right? See you in the next video. Well, hello, everyone. So in this video here, we're going to learn access modifiers or visibility modifiers in Kotlin. Access modifiers are used for setting the access level to classes, variables, functions, and constructors. There are 4 access modifiers in Kotlin, to be specific. The first one is private. So the private access modifier is accessible only within the class. Methods, variables, and constructors that are declared private can only be accessed within the declared class itself, right? The private modifier is the most restrictive access level. The second one is protected. And the protected access modifier is accessible only within the same class and additionally from all the subclasses of its class. The third one is internal. So the internal visibility modifier means that the member is visible within the same module. More specifically, a module is a set of Kotlin files compiled together, such as IntelliJ, IDEA module, or a Maven project. And the last one would be public. So a public access modifier is basically accessible from everywhere. This is the least restrictive access modifier. So here you can have a look at the restrictive level of accessibility of modifiers. And as you can see, the most restrictive modifier is private, least restrictive modifier is public, and then protected comes after private, and internal comes after protected. Right, so you don't have to use access modifiers when you're creating any object. I mean, this will not cause any errors. When you do become a good developer in the future, though, while working with different developers on really large projects, you may sometimes need to restrict the access of some of these other developers to the objects that you create. So what that does is prevent other software developers from using the objects that you have created, right? And basically creates a more efficient working environment. So in these cases, you may need to access modifiers here. And we generally use private or public access modifiers in our projects, but like I just mentioned, it's okay if you don't use them. Finally, I should point out, though, that if you do not specify any visibility modifier, public will be used by default, which then means that your declarations will be visible everywhere. Just keep that in mind, my friend. All right, so we'll just take a short break here. We're going to talk about naming conventions in the next video, so hang out, and I'll see you then. Well, hello, everyone. So now I want to teach you a couple of things about naming convention rules in Kotlin. The Kotlin naming convention is definitely a rule to follow how to name your identifiers, such as classes and variables and functions and, well, everything else. But, I mean, it's not a requirement, right? So that means it's known as a convention because it's not a mandatory rule and it's not going to cause any errors. Now have a look at the table here. Class name should start with uppercase letters and be a noun. For example, string, car, system, stuff like that. Function name should start with lowercase letters and be a verb, okay? For example, start, stop, action performed. Okay. A variable name should start with lowercase letters. For example, first name, year, color, etc. So by using standard Kotlin naming conventions, you'll make your code easier to read, not only for yourself, but when you share it with other programmers. The readability of the Kotlin programming is very important because it indicates not only that you know what you're doing, but you also understand what the code is for, what it does, and what its purpose is. However, the most important concepts of naming convention in Kotlin are case-sensitive and camel casing. So Kotlin is a case-sensitive language. For example, hello with the first letter uppercase and hello with the first letter lowercase are completely different in meaning, right? Camel casing is actually a naming convention where the first letter of the second word in a compound word gets capitalized. So you have a name that gets combined with two words. The second word will start with uppercase letters, always, all right? So I'll give you an example. Action performed. First name. And of course, you get the point. So naming conventions in Kotlin are pretty much respected throughout the community. So let's take a short break here, and I'll see you in the next one. Hello, friends. So in this video, we're going to go through the constructor. Now, this is a very important topic of object-oriented programming because a constructor refers to the first method or function to be called when creating an object from any class. So at least one constructor is required for each class. If you don't create any constructors, your compiler will create an empty constructor by default. And who wants an empty constructor? So now let's talk about constructors in Kotlin. The constructor structure in Kotlin can be a little different, my friends. There are basically two different constructors in Kotlin. The first is the primary constructor, and guess what the second one is? The secondary constructor. But the secondary constructor is similar to the constructor in Java. But the primary constructor is a little different. So a class in Kotlin can have one primary or one or more secondary constructors. You follow? So let's take a little look at the primary and secondary constructors now. The primary constructor is a part of the class header, and it goes after the class name and optional type parameters. If the primary constructor does not have any annotations or visibility modifiers, the constructor keyword can be omitted. The primary constructor cannot contain any code. Initialization code can be placed in initializer blocks prefixed with the init keyword. All right, so now let's have a look at the secondary constructor. So secondary constructors allow initialization of variables and allow you to provide some logic to the class as well. They are prefixed with a constructor keyword. And like I said earlier, the secondary constructor is quite similar to the constructor in Java. All right, so yeah, that's the theory. And you've learned about class, objects, and constructors. So really, though, what are we doing here? Are we just learning the theory? No, let's get to it. We're going to put it into practice. So go ahead, open up Android Studio. Now we're going to create a new project. So I'll select File, New, and New Project. And these are all in the top left corner. All right, so from this window that opens, I'll select Empty Activity and press the Next button. So now we're going to continue and configure our project from this window. So I'll set the name of the project to be Object-Oriented Programming. And I'm not going to change the package name and the file in which the project will be saved, so the programming language will be Kotlin. Finally, the minimum SDK, Let's call it 23. Now let's create our project by clicking the Finish button. Very cool. So our project is being created, and we shouldn't really take any action here. Just, hang out for just a little bit until it's fully created. You want it to be perfect, no errors. And of course, it depends on the performance of your computer. It might take a little while, but hey, I want you to pay attention though to this. From the Build tab up in here, you can see whether your project has been successfully created or not. So what you're looking at here is, yes, indeed, our project is completely created. So that means we can create a new Kotlin file. So I'll right-click on the project package folder in the project directory right here. I'll select the new Kotlin class file option. And from here, I'll just select the file option, and we'll give a name to this file. So the name of this file can be object class constructor. Of course, you could write any name that you want to, but okay, I'll leave it up to you. Anyway, we're going to create the Kotlin file by pressing the Enter key on the keyboard. So now we'll create a Kotlin class. And similarly, I'll just right-click on the project package folder with the mouse, select New Kotlin Class File. Now this time I do have to select the class option and specify the name of the class that I'm going to create. So we'll let the name of this class be cars, right? So please note that the first letter of the class in the file name, you see that? It's uppercase. So I create the Kotlin class named cars just by pressing Enter. And see how easy it is to create a class in Kotlin. Now again, I want you to notice that classes in Kotlin are expressed with the prefix class. Excellent. So now let's add a few properties to this class. For example, cars, what do they have? Names and models. So let's create variables that represent these properties. So here I'm writing var name column string. I write var model column int on the bottom line. And of course, I don't want to assign any value to these variables at this initial stage. But what do you notice? Android Studio throws up a warning. It wants us to initialize these variables. Well, who are you going to call? Well, never mind. Who are you going to trust? In any event, if you do remember back some previous lessons ago, when we created any variable inside the function, we could not initialize this variable, right? So in other words, we could pass values to variables later on. But in Kotlin, we absolutely need to initialize the variables that you create in a class. So now, there's a couple of different solutions at this stage. So first, we can assign an empty value for string variables. So if we just put double quotes on the right side of the equal sign, we actually initialize it, but pass in a null value. Or if we write 0 on the right side of the equals for integer variables, we're still going to initialize the variables. We can then pass the values that we want to pass to these variables. So that is the first method. But see, in this method, we still assigned a value to the variables. So let's have a look at the second method. Now, in the second method, after the string or integer expression here, we can put a question mark and write null on the right side of the equal sign. So this method is called nullable in Kotlin. In fact, it's thanks to this method the null errors that we frequently encounter in Java are prevented. Now, because we can define variables without assigning any variable, we prevent the program from throwing up any errors, even if we forget to transfer value to the variables later. Now, you will understand why that's important better with time, but for now, it's enough to know that we'll just write it this way, and we'll be able to define variables in the class without initializing them. All right, so thus we have now determined two different properties of the class named cars. Now let's return the Kotlin file that we just created. So from this file, we can access variables or properties in the class named cars. So for this, we need to create objects from the class called cars. Of course, we need to do the object creation process in the main method, because Kotlin needs at least one main method. So I'll type main A here and press enter. And as you can see, the main method has been created, so we can go ahead and create an object of the class cars. So for this, I've got to write var here and specify a name for the object that I will create. I'm writing my car, and of course you could give it any name you want to. Now notice too that the variable consists of two words. The first letter of the first word is lowercase. The first letter of the second word is uppercase, right? That's the camel rule. So after determining the name of the object that we're going to create, we just need to put the equal sign and write the name of the class from which we will create the object. So I'm just writing in cars here. Now, did you notice the cars class suggested by the code editor is the cars class in the package we created? So if we select this and put the parenthesis at the end, we will create an object of the class named cars. So now, using this myCar object, we can easily access the features and functions in the cars class, if there are any. So for this, we'll put a dot after typing myCar here. So after putting a dot, the features in the cars class and the functions, if any, will be presented to us by the editor. All right, so that way we can use that feature. You just thought it was magic. So first, I'll select the name property from here, and I'll give a name to the car. So let's call it Ferrari. Now let's determine the model of the car in a similar way. So I'm writing the mycar.model, and we're going to go with the model to be 2021. So we'll just keep it by year, model year 2021. So now we're going to print the name and the model of the car on the console. I'll type S out, press enter. I'll write my car's name is mycar.name, and its model is mycar.model in parentheses. All right, so now let's run our code. So what you're looking at here is we can see the name and the model of the car on the console screen. But the point that you really do need to pay attention to is this. We have defined any variable named name or model in the main method. But thanks to the object we created from the cars class, we have assigned the cars class, and we have passed a value to the properties named name and model that are defined in that class. You follow? So we were able to display these values in the console because of that. So that is the basis of object-oriented programming, my friends. So if you get the concept, right, you're not going to have any difficulty at all when you're developing applications or even learning a different programming language. So if you did trip up a little bit, that's okay. Just go back and review, and pretty soon it's not going to be a problem at all. So here we have created only one object from the class named cars. But of course you can create as many objects as you want. So for an example, I'm just going to create one more object, and then we'll just call it quits here. So I'll write var mycar2 equals cars. This time the name of the car is Mercedes. And here I'll write mycar2.name equals Mercedes. So now let's define the model. So I'm typing mycar2.model equals 2010. Now let's print this to the console. So I'm typing here the first expression. I'm copying this and pasting it on bottom line. I'm typing the second here, and I'll organize these objects as mycar2. Cool. So now let's run the code. All right, so as you can see, we see the name and the model of the first and second car in the console. So that way, you can create as many objects as you want and then transfer different values. All right, so we'll break right here, and then we're going to practice our constructors in the next time we meet, next video, all right? So see you on the other side. All right, hello friends. So in our previous lesson, we talked about constructor theoretically, but we also learned how to create classes and objects in Kotlin practically, right? So that means in this lesson, we're going to do a little practice with constructor. All right, so let's get to it. Now, hopefully you remember we created a Kotlin class called cars in our previous lesson. Now, this Kotlin class also had two properties, name and model. We also created two objects of the cars class in the main method. Great, and then using these objects, we passed some values to the name and the model variables. Now, did you notice we first created an object and then passed a value using the object? So what do you think we ought to do if we wanted the user to transfer these values while creating an object from any class? So this, you understand what I'm saying, right? Well, I'll tell you, because we're going to make a constructor. The constructor was the first method called when creating an object from a class. So why don't we do this? Let's create a new class right now, and we'll try to understand the constructor just a little bit better using this class, all right? So first, just right-click on the project package folder, choose New Kotlin Class File option. Now here, the class is going to be selected, so why don't we call this class mycars. I'll create the Kotlin class just by pressing Enter. Now, do you remember when we talked about the constructor in the previous lesson, we talked about two different constructor structures in Kotlin, and these were primary and secondary, right? So we'll have a look at the primary constructor first. To create a primary constructor, we'll write the constructor expression after the class name. When we start to write the constructor, the code editor proposes that constructor to us. Select it, press Enter. Now, write the name and the model variables in parentheses. Cool. So here I'm writing var name : string. And after putting in a comma, we can define the model variable. So I'll type var model : int. All right, so here we've created the primary constructor. So now let's create an object of this class in the main method. We'll turn the codes that we wrote in the previous lesson into a comment line. Let's write creating an object from class here. That way you'll be able to understand these codes a little bit more easily when you go back and review them. All right, so let's create an object from the mycars class. And here I'm typing var myNewCar equals mycars. And see how Android Studio gives a warning? Because we need to enter a name and model parameters in parentheses, because we wanted the name and model parameters to be entered in the constructor, right? Now at this point, hopefully you understand the purpose of the constructor. You see, if we did not use the constructor, we could create objects without entering these parameters. However, sometimes we may want to enter some parameters while creating objects with the projects that we develop. You follow? So in this case, it is best to use a constructor. All right, so without any further ado, let's enter some parameters. I'll write Ferrari as the first parameter. Write 2021 as the second parameter. Now let's print these values to the console. I'll type S out and press enter. I write my car's name is mynewcar.name. And its model is mynewcar.model in parentheses. Now let's run our code. All right, so as you can see, we've printed the name and the model of the car on the console, okay? So that's how you use the primary constructor. Now I want to show you something, how to use the init keyword. So in Kotlin, you wouldn't be able to directly write a block of code inside the primary constructor. If you want to write some code, you should be doing so using the init keyword. So I'll give you an example. Let's try to print the name and the model of the car to the console, not in the main method, but in the constructor of the myCars class. All right, so I'll first convert this line of code into a comment line. All right, so now let's go back to the myCars class. I'll write S out here, but as you can see, we cannot write S out. More precisely, we encounter this error when trying to write it. Okay, so this is because no code can be written directly into the primary constructor. So for this, we need to use the keyword init. So after typing init here, I'll select the init expression suggested by the code editor and press enter. What happens next? A block is formed for us. So now let's try to write S out inside this init block. And as you can see, we don't encounter any more errors. So I create the print in method by pressing enter. In parentheses, I'll write my car's name is $name and its model is $model. Let's run our code again. And here you can see we were able to see the name and the model of the car on the console screen. So my friends, that is using the primary constructor in Kotlin. Now, let's have a look at the secondary constructor, all right, because we've built it up pretty big here, huh? I already told you that the secondary constructor is similar to the constructor in Java. So that means you can create multiple constructors using the secondary constructor. Of course, if there are any friends out there who know Java programming, we could create empty and full constructors in Java, right? You can create empty and full constructors just by using the secondary constructor in Kotlin as well. So let's do that right now. First off, we'll create a new class. So in fact, we can explain all of these concepts through the same class, but since I do want to share these codes with you, I just want to examine them a little more easily. So for that reason, I'm just going to explain it in separate classes as much as is possible, all right? So here we can just put the name of this class to be my second cars, all right? So now let's create two variables for this class. So here I can type var name column string question mark equal null. Just below the line, I'm typing var model column int question mark equals null. Now, let's create the secondary constructor. There are actually two different ways to create it. The first is manually. The second one is using a shortcut in the code editor. So I want to show you how you do it manually first, because then you'll understand what the shortcut does. So when I write the constructor here, I'll select the constructor suggested by the code editor and press enter. Now, if you leave it that way, it is expressed as an empty constructor. But we will create a full constructor. That is a constructor that includes both variables. So for this, I'll write the name column string in parentheses, and I'll write the model column int after the comma. Now, I'll open curly braces and specify the scope of this constructor. Here, using the this keyword, we will pass the name and model information that will come from the main method with the help of the constructor to the name and model variables that we have created here. All right, so let's do this right now. So I'm just typing this dot name equals name here. And this is the first time that you see this type of writing, you know. So let's try to explain a little bit. This keyword represents a class to which the method is bound. So here it represents the mySecondCars class. So the name that comes after this statement represents a variable named name that we created in the class, right? The name that we write to the right of the equal sign represents a value that we will specify in the main method with the help of the constructor and will be transferred to the variable named name. You can also write a different expression instead of name here. For example, you can write n instead of name. It's not going to cause any errors, but the secondary constructor is generally adaptable in this way. So, similarly, now I can write this dot model equals model. So we created the secondary constructor like that. So why don't we do this? Let's create the secondary constructor using the shortcut in the code editor. So let me just delete the constructor here. I'll right-click on the empty space. Choose the Generate and Secondary Constructor options from the pop-up menu. So if you notice, we can see the variables named name and model in this window. And if you press the Select None button without selecting these variables, you will get an empty constructor. But right now, I want to right-click and select the Generate and Secondary Constructor options. That would be an interesting new word, huh? Anyway, this time I want to choose both variants. So you can select both variables just by pressing the Control key on the keyboard. So I'll create the secondary constructor by clicking the OK button. And as you can see, the secondary constructor is created automatically, just like that. Now, of course, you could use either one of these two methods, however and whenever you want. But now I want to create an object of this class in the main method. So here I will write var mySecondCar equals mySecondCar. Now notice that although we create the constructor, we do not get an error, even if we don't write any parameters in the parentheses. Can you tell me why? Well, I'll tell you. It's because we are creating an empty constructor, right? So why don't we do this? Let's turn the empty constructor in the class mySecondCar into a comment line. Now, if we look at the main method, as you can see, we are now getting an error, right? Because there's only a full constructor and we need to enter parameters here. So what do? I'll write Mercedes as the first parameter. I'll type in 2000 as the second parameter. Now, let's print this to the console. So I'm copying the line of code here and pasting it here. I'll type in second here and also arrange these objects as mySecondCar. Now we can run our code.
As you can see, we have printed the name and model of the car on the console. Yes, friends. This is how to use the primary and secondary constructors in Kotlin. I hope it has been a useful lesson for you. Before I end the lesson, I want to show you one more thing. Notice that we have set the value of the variables named name and model during object creation. This was because we created the constructor. Well, can we change the values we assign to the objects named name and model? In other words, is it possible to change the values we assign while creating an object later? Let's explain this situation with a simple example. Currently, the value of the variable name is Mercedes and the value of the model variable is 2000. Now let's change these values. Here I write my second car, .name equals. This time let's name the car Opel. Similarly, let's pass a value to the model variable. I'm writing my second car, .model equals. Let's transfer the value of 10 to the model variable. So, when we run the code, do you think we will see the new values or the old values on the console screen? Any ideas? Let's run the code and see together. And as you can see, we saw the new values, namely Opel and 2010 values, on the console screen. This is because the set method is automatically created in the Kotlin programming language. If you want, let's end this lesson here, and in the next lesson let's focus on set and get methods and encapsulation. See you in the next lesson.
Well, hello, my friends. So we've already learned the primary and secondary constructors, right? And we also saw that we can change the properties of the object that we create from a class later on. But sometimes in the projects that we develop, after assigning a value to an object, we may want the assigned value not to be changed. So in these such cases, we should use the method called encapsulation. So why don't we just dig right in without any further ado, open up Android Studio, and let's get into this encapsulation process. Now, I'm sure you remember after we determined the name and the model of the object named my second car, back in the previous video, we were able to change it again. So what should we do if we don't want these properties changed again later on, after we've already determined the first property of the object named my second car using constructor? Well, that's right. I think I heard a couple of you say, yeah, what about the visibility modifier? So indeed, let's use the private visibility modifier. So for those of you who haven't read that far ahead, why don't we go ahead and learn how to do it? So I want to open up the class called my second cars. Now in this class, we've defined two variables named name and model. Let's make the model variable private here. All right, so I'll just type in private. Now the model variable has a private visibility modifier. So in other words, the variable named model can only be accessed within the my second cars class. So to, better understand it, let's reopen that Kotlin file. And what do you see? We cannot change the model of the object named my second car because the model variable is now private and can only be accessed from the class it is in. Cannot be accessed from anywhere else. All right, so if you don't want an object's properties to be changed a second time, you really should use the private visibility modifier. That's the process called encapsulation. Now, of course, it is worth mentioning one more thing here. I want you to notice that after making the model variable private, we cannot retransfer the value. We also wouldn't be able to read the model variable. So what should we do if we want to read the value of the model variable? Well, at this stage, we'll need to set and get. In fact, the operation that we do here, that is the value transfer operation, is the set operation. So the operation that we do here, that is the operation to read the value that we transfer, is the get operation. All right, so we can block the set operation. And what do you think? Can we block the set operation and allow the get operation? Well, why don't we have a look? So I'm reopening the mySecondCars class. First of all, we'll delete the private statement here. Okay, so now let's have a look at this subject through the model variable again. So from the line where we defined the model variable, we go to the bottom line by pressing Enter, then press a Tab key, and I'll write private set. So this process only makes the set making process private. So we can no longer pass a new value to the model variable, but we can read the value of the model variable. You can even write get on a bottom line. So now let's go back to the Kotlin file. And as you can see, we cannot change the value of the variable named model, but we can read the value passed to this variable. That's because the set operation is private. What do you think? I think that's really cool. So thank you, my friends. That's how you use encapsulation. Set and get in Kotlin programming. So why don't we take a short break, all right? Because next time we're going to learn about inheritance. All right, so I'll see you in the next video. Hello, everyone. So, you know what? You've been chomping at the bit. I know it. You want to learn about inheritance. So, inheritance is an absolute fundamental concept of object-oriented programming. So, it's used when we have an is-a relationship between objects. So in Kotlin, all classes can inherit variables and methods from another class. And inheritance enables us to reuse existing code. So I'll show you in our example, we have this superclass vehicle. Now all vehicles have a type, model, and a max speed. Also, all vehicles can start and stop. All right, so we understand this to be the base class, okay? Now, also, we have two classes here named car and motorcycle. Car and motorcycle classes are subclasses of vehicle. So we use the colon sign by the subclass to inherit the features of the superclass. So the car and motorcycle classes inherit variables and methods from the vehicle class. And there's no need to declare these variables or methods again for the car and motorcycle classes, right? The car class has its own variable. This is named isAutomatic. The motorcycle class has its own variable that's named motorType. Now, finally, I want to mention this. In these Kotlin classes, so Kotlin classes are final by default. In fact, I'll put it another way. The final modifier marks classes and methods as no way, not allowed to be overridden. Therefore, in order for subclasses to inherit from superclasses, the open statement must be written before the class statement in superclasses. You follow? It can be inherited from a superclass only by using the open statement. All right, so now that you know that, let's open Android Studio and get some practice in. So first I want to create a new class. I'll right-click on the project package folder with the mouse. Choose New Kotlin Class File. I'm specifying the name of this class, Vehicle. So let's start to write a program that prints the properties of subclasses using inheritance. Vehicle class, that's my superclass. Let's declare 3 instance variables in the vehicle class. We declare 2 variables that are named type and model with string type. And variable max speed with this int type. Now let's declare a void type method show to display values of type, model, and max speed variables. And for this, we'll use the printin method. I'll write s out and press enter. Inside the parentheses, I'll write type $$ type. Copy and paste this code twice. And then I'll write model : $model. And next up, I'll write max speed : $max speed. All right, so there we have my superclass is now ready. Okay, so let's start to declare subclasses. Okay, let's create a new subclass. Right-click on the package and select New Kotlin class file. Specify class name car. Now, in order to implement inheritance, we have to add the : sign after the subclass car. Our subclass car inherits from superclass vehicle. So this means that subclass car inherits the show method and the variables from superclass vehicle, right? Now also, I'm sure you notice Android Studio does issue a warning, right? And that's because, as I was trying to tell you in the beginning of the lesson, the vehicle class is final by default. Also, since the empty constructor is also created by default, we've got to define it here as well. So I'll show you how. Let's select the Change to Constructor Invocation option here. And as you can see, the warning still persists. You thought I was going to make it go away. But I do want to show you this. How to fix this error. We'll need to make the vehicle class open, right? You remember I was, telling you the theory. So here, when you make the vehicle class open, and by the way, you can also do this by clicking here, or in the vehicle class, you can fix this error by using the open keyword before the class statement. And of course, that's your choice. But here it is, error's gone. Also, car class empty. So why don't we create another subclass? Right-click on Package and select New Kotlin class file. Specify class name motorcycle. Our subclass motorcycle inherits from superclass vehicle. So this means that subclass motorcycle inherits the show method and the variables from the superclass vehicle. Also, the motorcycle class is empty, right? Okay, so now we can create a new Kotlin file for the test of this inheritance concept that I've been trying to convince you of. All right, so right-click on the package, select New Kotlin class file, select the file option here. Specify class name as inheritance test. We could also do this in the object class constructors file, but since we use that file a lot, I just want to show you through this new Kotlin file. And also, I'm going to create a main method. So here now we can start to create a new car object. So I'll write var car equals car. And if you write car object and dot operator, then you will see the variables max speed, model, and type, and show method coming from superclass vehicle. All right, so notice that we didn't create any variables or functions in the car class. However, since the car class inherits from the vehicle class, we can access all of these properties and functions in the vehicle class. So we'll assign the car value to type variable, Ferrari value to model variable, and value 320 to max speed variable. And we'll call the show function from the superclass vehicle. Okay, so let's run the code. And there you see the results in the console. type is car, model, Ferrari, max speed 320. All of these properties are inherited from superclass vehicle. So now I want to create a new motorcycle object. So I'll write var motor equals motorcycle. Now when I write motor dot, you see the same properties and methods coming from the superclass vehicle? So let's assign motorcycle value to type variable Yamaha value to model variable and value 180 to max speed variable. And let's call the show method from superclass vehicle. All right? Cool. So now let's run the code. And there you got the results in the console. Type motorcycle, model Yamaha, max speed 180, put a helmet on. All right, my friends. So it's because of inheritance. You can easily use the same properties of a class in more than one class without redefining them. So there you go. That is inheritance. So I'm glad we went through all that. We're going to take a short break here, and I'll see you in the next lesson. Hello, my friends. I'm so glad to see you back. Just playing. So now we're going to learn about function overriding. If you define a function in a subclass that's already defined in superclass with the same name, same parameter, and same return type, well, yes, you can do it. It's actually known as function overriding. So in this case, the function in the superclass is called overridden function, and the function in the subclass is called the overriding function. In fact, I just want to do a simple example here to help understand it just a little bit better. So we've got two classes here, a superclass vehicle and a subclass car. The car class inherits from the vehicle class. Both of them have a common function named stop. The car class gives its characteristic to the stop function, so it overrides the stop function. It prints car has stopped instead of vehicle has stopped. You see how that works. We're going to do a few more examples, though, so that we can really get this function of overriding. So first of all, we're going to create a new package, and we're going to do the override operations within this package. Now, it's okay if we don't create this package, but again, I don't want it to interfere with the classes here, since I will be creating similar classes called vehicle and car. Okay, so just to make that point, I just want to create a new package. Gosh darn it, all right. So here I'll just right-click on the project package folder with the mouse, choose new package option. So let's give this new package a name. I'm going to just write override as the name of the package. And now we can create a class. I'll right-click on override package, choose new Kotlin class file as my option. And I'll set the name of this class, make it vehicle. Right, so now vehicle is our superclass. We're going to declare 3 public unit functions in the vehicle class. The first function will be start. We print the vehicle has started message by using the printin function. Second one's going to be accelerate function. So this function will take one parameter. The name of the parameter will be speed, and it will be of the integer type. We print vehicle accelerates according to given speed. We use the speed variable in the printin function. And then we'll make the last function stop. Now in the stop function, we'll print the vehicle has stopped as a message just by using the printin function. Okay, so let's create a new subclass. So right-click on Overriding Package and select New Kotlin Class File. Specify class name, car. Now, in order to implement function overriding, we have to add the colon sign after subclass car. Also, we've got to take this vehicle superclass and make it open. So our subclass car inherits from superclass vehicle, and this means that subclass car inherits all functions from superclass vehicle, right? Car class is empty now. So the question is, well, why do we even need function overriding, right? Well, let's create a Kotlin file in the same package. So I'll write override test as the name. And let's create the main function. In the main function, we will create a vehicle object. I write var vehicle equals vehicle. First, we call the start function from the vehicle class, and then we call accelerate function by passing a value of 80 as the speed, and that'll be the parameter. And last, we'll call the stop function. So what happens when we run the code? Well, you can see the results in the console. The vehicle has started. The vehicle accelerates at and up to 80, and then the vehicle has now stopped. All right, you with me? So let's create a car object so that we can test this out. So we call the start function, then call the accelerate function by passing the value 100 as the parameter, and call the stop function. Now, before running any code, let's make a partition here. This way we'll be able to see the two sections separately in the console. So what happens when you run the code? You see the same results. Vehicle is started, vehicle accelerates to the speed of 100, and vehicle has stopped. But you see the problem. We weight properties of car, not vehicle, in the second part. So we need to override the functions of the superclass vehicle in the subclass car. You follow? Let me show you. Let's override these functions, open the car class, and we'll copy the functions of the superclass vehicle. Now let's paste the copied methods into the car class. So as you can see, Android Studio, hey, no, wait, stop. Because the car class inherits from the vehicle class. So it can access these methods directly. Therefore, it considers it a mistake to use these methods here with the same name and the same parameters, and it's going to tell us if we still want to use these methods here, we must override them. We will do the override process as follows. All right, we actually need to write override at the beginning of each method before the fun statement here, my friends. All right, so now let's do this for all three methods. But wait, there's still warnings because methods are also final by default. Now, to resolve this error, all we need to do is make each method open in the superclass. That is the vehicle class. So why don't we go ahead and do that right now? And as you can see, when we make the methods open in the vehicle class, the warnings disappear. All right, my friends, so as a result, we override the methods of the vehicle class in the car class. So let's make the changes for implementing properties of the car class. So we'll print car has started in the start function instead of vehicle. We print car accelerates according to given speed instead of vehicle. And we print car has stopped in the stop function and again instead of vehicle. So these three functions have the same name, same parameter, same return type with the functions in the vehicle class. Okay, so now let's open up the override test file. Cool, so now we can run the code. And what do you see? Two different messages coming from the functions of classes. In the first part, we display the messages from superclass vehicle. In the second part, since we override the functions of the superclass vehicle in the class car, car has started, car accelerates at speed 100, and car has stopped. These are the messages that are now displayed. Right? So that's function overriding. And I think it's pretty doggone clear. Go back and, finesse anything if you need to. But before we close out this section here, I do want to mention this keyword super. So follow my thinking. What do you think we would do if we want to create a function in the car class that does the same thing as the functions in the vehicle class, but with a different name? I might have given you too big of a hint or clue, but yes, we can use the keyword super. Just want to show you a quick example. So within the car class, I'll create 3 functions. Let the first function be called super start. Let the second function be called super accelerate. Let the third function be called super stop. All right? So now, let these 3 functions do the same operation as the 3 functions in the vehicle class. For this, inside the first function, after typing the keyword super and putting in a dot, I can display the functions in the vehicle class. The keyword super here represents the super class that we inherited, the vehicle class. So here I choose the start function. Similarly, I'll type super.accelerate. Finally, I'll write super.stop. And now inside the main method, let's call these functions. So here I'm typing car.superstart first. Now I'm typing in car.superaccelerate. Then finally I'll write car.superstop. Now let's also copy and paste this line of code here. Now let's run and test our code. And there you see it. Although the function names that we created in the car class are different, we have used the super keyword to perform the same operation as the functions of the vehicle class. Wow, that was packed. So my friends, thanks for listening, but that's how you do an override operation and how you get to use that super keyword. It's a super keyword. All right, my friends, we're going to take a break here, but I want to see you in the next video. Well, if you're here and I'm here, we must be in the next video. So cool. Hello, my friends. So right now I want to talk about the concept of this abstract class. All right, so I would say that the most important feature that'll distinguish abstract classes from other Kotlin classes is that we wouldn't be able to create any objects using abstract classes, all right? Now, sometimes, according to the project that we develop, we might not want to create objects from classes, but we might want the functions or properties defined in these classes to be used. See where I'm going? So in that kind of case, and you might not be able to speculate yet where you would use it, but we would create the abstract class. All right? So to create an abstract class, you just got to use the keyword abstract before the class prefix. But also to create an abstract function or property, we have got to use the abstract keyword before declaration words, such as fun and var and val. So why don't we just open up Android Studio and get some practice in? So you know what to do. Follow along with me if you're not already there. So create a new package. Right-click on the project package folder. Choose New Package option. And we'll let the name of this package be Abstract. So now I want to create a superclass and a subclass in this package. Right-click on the package, select New Kotlin class file. And here the class will be selected. So I will set the name of this class to be variable. All right. So vehicle class will be superclass. I'll also make this class abstract. For this, I'll just write abstract as my keyword before the class statement. So now let's define some properties and functions within this class. Now, some of these functions and properties will be abstract. So first, we'll create a function called vehicle name. This function should take a parameter, and that parameter is name. The type is string. It also returns a value of type string. Now note that I'm not creating the body of the function. So I didn't specify the scope of this function with curly braces. So that's why we're getting this warning. So we've got to either make this function abstract or create this body. And yeah, because this is the time when we're focusing on abstracts, we'll just make this function abstract. So again, I will use the keyword abstract before the fun statement. And as you can see, the warning has now vanished. All right, so let's define another function. We'll let the name of this function be vehicle type. Now this function should also take a parameter named type and type string. Also, this function here returns the value of the type string. Now this time I'm not going to make this function abstract. So I'm going to create the body of this function. You follow? So here I'll just write return type, and this function will return the type of vehicle. So as you can see, we may recognize functions as abstract or non-abstract. But what's really the difference between these two functions? We'll get to that in a minute. Right now, we're going to define two properties. And again, let's define these variables as abstract and non-abstract. First of all, I'll define a property named model and type string. If I leave it that way, Android Studio does give us a warning. So in other words, I've got to abstract or initialize this variable. So I'm going to make this variable abstract. I write the keyword abstract before the var statement. But now let's create another property. I will create a variable named speed of the type integer. This time I will initialize this variable, but I'm going to initialize it as null. So I can set the value of this variable later, okay? All right, my friends, so as you can see, we've got two functions, two features that we've created here. The function that we created as an abstract has no body, and we did not initialize a variable. So right now, with that hanging in the balance, let's create a Kotlin file now. I'll right-click on the abstract package, choose New, Kotlin class file options. File type will be file. I also set the name of this file to be abstract test. So now we've got to create our main method. And we will try to create an object from the vehicle class that we just created. So here I'll write var vehicle equals vehicle. And notice here that I've selected the vehicle class in the abstract package here. As you can see, Android Studio warns us. If we hover over to this warning, the code editor tells us that the vehicle class is an abstract class and we cannot create an object. But remember what I said at the beginning of the lesson? The biggest feature of abstract classes is that we cannot create objects from these classes. Okay, those are the rules. Might seem a little pointless then, huh? or maybe it's confusing. But when you work on really large projects in the future, you can create multiple classes, and you may want some functions or properties to be used in all classes. So that's the time that you can create all common functions and properties under an abstract class. In addition to all that, you can create this class only to use common functions. And you can prevent the creation of objects from this class. You'll understand why shortly. But first, I want to show you that we will create a subclass. So now I'll just right-click on the abstract package, choose New, Kotlin Class File option, and its type's going to be class. I'll set the name of this class to be car. This class will inherit from the vehicle class. I write vehicle after the colon. And what you see here is Android Studio throws up a warning because there is one property and one function that we've defined as abstract in the vehicle class. So we need to implement this feature and function here. So from here, I select Implement as Constructor Parameters as my option. And from here, I select the model variable, press the OK button. And as you can see, we override the property named model, which we created as abstract in the vehicle class. So it's a constructor here. So now let's implement the function. I select the implement members, select the vehicle name function, and press OK. So as you can see, we have now overridden the function named vehicle name that we've created as an abstract in the vehicle class. Now, I want you to notice we do not need to override the functions and the features that we define as non-abstract. Okay, it might still be a little abstract, but that's the functions or variables of this abstract class and how to use them. So why don't we just return, we'll write a return name here, and this function will return the vehicle name. And we'll create an object from the car class in the main method. So I'll write var car equals car. Now we must write the model parameter in parentheses. So I'm writing 2021 here. And on the bottom line, when we type car dot, we can access all the functions and features that we defined in the vehicle class. So first I'll choose speed. So we'll let speed be 300. Now let's print all the properties to the console. I'll type S out and press enter. I will write name, colon, in parentheses, and write the name of the vehicle. I'll open up a curly bracket after the $sign and write the car.vehicleName function here. I'll write Ferrari as a parameter inside the parentheses. I will not create a separate print-in method for each feature. I can define them all in this method. So for this, I'll write \n. So this syntax is used in Spring expressions to jump to the next line. So that is, on the console screen, the phrases after \n are displayed on a bottom line. So now let's write the type of the vehicle. I'm writing type colon $car dot vehicle type. I also write car as a parameter. Since it does not fit on the screen, let's write it on a bottom line. And then by pressing enter, I'll go to the next line. And again, I type \n and press enter to switch to the next line. Now let's write the model of the vehicle, and I'm writing model colon $car dot model. And I type again \n. And again, by pressing enter, I'll go to the next line. And then finally, we'll write the speed of the vehicle. So I'm writing speed colon car dot speed. Now let's run our code. Cool. So as you can see, we've printed the vehicle's name, type, model, and speed to the console. All right, my friends, that is abstract classes in a whirlwind, right? We're going to take a short break. Don't worry about it. And in the next lesson, we're going to go through the interface. So I'll see you then. Well, hello there, my friends. So I think we talked about abstract classes enough, right? All throughout the previous lesson, and you mastered them. So that means in this video, we're going to learn the concept of interface, and that means we're going to finish object-oriented programming. What? Yeah. So interfaces are custom types provided by Kotlin. Okay, now these cannot be instantiated directly. Instead, these define a form of behavior that the implementing types have to follow. So with the interface, you can define a set of properties and methods that the concrete types must follow and implement. Now, interfaces are also abstract. So in other words, they have the characteristics of the abstract class that we learned in the previous video. So we don't use interfaces to create objects, okay? The purpose of interfaces is this. In Kotlin, a class can inherit only one class. It cannot inherit from more than one class. So in our projects, if a class needs to inherit from more than one class, well, we need to define these classes as, drumroll please, interfaces. All right, so creating an interface is also quite simple. The interface definition in Kotlin begins with the interface keyword, followed by, guess what? The name of the interface, followed by the curly braces within which the members of the interface reside. So the difference is that the members will have no definition of their own. All right, so these definitions will be provided by the conforming types. So that means that we should open up Android Studio and get some practice. So here we're going to create a new package, and I'll specify the name of this package, call it interfaces. So now let's create one class and two interfaces in this package. First, I want to create the class, so I'll right-click on the interfaces package, select New Kotlin Class File. Its type will be class. I'll define the name of this class. I will not define any functions or properties inside this class. Now, of course, you could create it if you want. Now, to move on, let's create the interfaces. So I'll right-click on the interfaces package, select New Kotlin Class File. Now, this time I'll choose Interface from here. And we'll let the name of this interface be Can Go. All right, so I'll press Enter. Stay with me. So as you can see, we've created the interface. And within this interface, you can create functions or properties just like in abstract classes. So first, let's create a function. I'm typing fun go here. Remember, in abstract classes, we had to either create the body of the function or write the abstract keyword at the beginning of the function, but interfaces don't need this. So if you want to, you can leave it that way and create the body of the function after the inheritance. Or you should create the body of the function here. So let's create it here for now. So we'll let this function print vehicles can go to the console. Let's create the variable, and here I'll write val name :string. You cannot initialize the variables that you define in the interface, but I want to show you what happens if you try to initialize it, because it's kind of fun. So I'll write equals Ferrari. And look at that, we're getting an error. Okay. Properties in interface cannot be initialized. You know that now if you didn't before. So what can you do? You can pass a value to variables using the get method that we learned a little bit earlier. So I'll go to the next line by pressing Enter and press the Tab key. Now I call the get method. Now we can write Ferrari in here. And of course, if you notice, we have defined this variable as val. So we would still get an error if we defined it as var. Why? Because you wouldn't be able to change the properties that you defined in the interface anytime after you defined it, right? So that's why I'm deleting this get method for now. All right, so let's create another interface. So I'll right-click on the interface package, select the new Kotlin class file, and the type it will again be interface. So I'll set the name of the interface can stop. Now, let's create a function in this interface. So I'm typing in funstop here. This time, I will not create the body of this function. Now let the vehicles class inherit from the interfaces that we created. First, let the vehicles class inherit from the interface named canGo. As you can see, the code editor warns us because there is one feature that we need to implement. So from here, we can select the Implement as Constructor Parameters option, just as we did in the abstract classes. Or by selecting the More Actions option here, we can view other actions that we can take. Or, after clicking this warning with the mouse, if we press the Alt and Enter keys on the keyboard, we can view all the options that can be made. So this time I'm just going to choose Implement Members option from here. So as you're seeing, we override the property named name here. Also, the get method has been created. So if we created this get method inside the interface, we wouldn't need to override it here, right? So now let's just pass in a value to this variable. Here I'll just type in Ferrari between double quotes. Great. So now let's make the vehicles class inherit from the canStop interface as well. So to do that, I'll just put a comma here and call the canStop interface. And as you can see, a class can inherit from more than one interface. If the canGo and the canStop interfaces were classes, we would not be able to inherit from each. So this is the most important feature of interfaces. Let's just pause for a moment and drink it all in. Okay, because if you notice here, Code Editor will give a warning because there's a function that we need to implement. So after clicking here, I'll press Alt and Enter. From the keyboard, I'll choose Implement Members as my option. And as you can see, we override the stop method with its body. If you create the body of the function in interface, you don't need to implement it in this way. So just like the start function in the canGo interface, remember? Now this function also prints vehicles canStop to the console. So now let's create a Kotlin file for the main method. I'll set the name of this file to be interface test. Now let's create the main method, right? So first of all, we'll create an object from the vehicle class. I'll write var vehicles equals vehicles. Notice I'm choosing the vehicles class in the interfaces package. First, let's print the name of the vehicle on the console. I'll write vehicles.name, and we can even write this in the printin method directly. I'll type sout, press enter. I write name : $vehicle.name in parentheses. Now let's call the go and stop functions. So here I'm writing vehicles.go. I also write vehicles.stop on the next line. Now let's run our code. And there you can see we have printed the expressions Ferrari vehicles can go and vehicles can stop right on the console. All right, my friends, that's how you use interfaces in Kotlin. Now, boy, it kind of feels bittersweet, doesn't it? We've finished object-oriented programming. Also, we've come to the end of our course. So I want you to go ahead, take a short break, let some of that trickle down or filter in or whatever you need to do. But in the next video, I want to take a look at what we've learned throughout the course because you're going to be amazed. All right? So we'll zoom out a little bit. All right? I'll see you in the next one. All right. So here we are, my friends. We have now come to the end of our Kotlin programming course. Now, before we get too sad, I want to mention a couple of things. First of all, I hope this course has been useful and as fun for you as it has been for me. But I'll tell you why I know it's very useful for you, because we're going to have a look at what we've learned. First of all, you certainly got a lot of information about the Kotlin programming language and the Android ecosystem. Remember, we made the necessary installations to be able to use Kotlin programming as a language. You thought it was kind of simple, but then we learned variables, data types, arrays, operators, control flow statements, and loops. And we learned how to use all of them in this Kotlin programming language. Then we got into the object-oriented programming. And we learned from this context how to use functions and classes, object creation, encapsulation, inheritance, function overriding, abstract classes, and interface. So thus, we have touched on all the topics that you need to know about Kotlin programming language. So I sincerely hope that you enjoy the course. Please share your feedback with us so we can produce even more and better courses for you. I really, truly do hope to see you on another one. All right? It's goodbye for now. See you next time.